Good morning, everyone. This is Darmadi Como from SQL Server Marketing. We're very happy today that we have a good sessions for you. The topic we're going to talk about today is SQL Server in Windows Azure Virtual Machine. And we're going to go through the agenda for today quickly to show you what we have planned for you. The very first one we'll start jumping in is SQL Server in Windows Azure Virtual Machine overview. Louis is going to help me doing that. And then we'll jump into the second session, which is SQL Server on Windows Azure Virtual Machine performance tuning, and follow with the data warehouse in SQL Server Windows Azure Virtual Machine, and finally business intelligence as well, right? So we'll have a good set of agenda for you, and we're very excited to share this with you. So with me today, I have Luis from engineering. Luis, can you tell us who you are and what are you going to talk about today?
Absolutely. Thank you first for calling me here. So my name is Luis Vargas. I'm a program manager lead on the Windows Azure VM support for SQL Server. So basically, our team handles running SQL Server on the Windows Azure infrastructure and making sure that Windows Azure is the best platform for running SQL Server. So we work on that. We also work on what we call hybrid scenarios, which is offering cloud services to our on-premise customers. So people who are running SQL Server on-premise in their own corporate environments, offering support for from the Windows Azure perspective. So today we're going to be talking about 4 topics as part of the talk. First, we're going to introduce what we call the SQL Server Cloud Continuum. And that is basically the path between on-premise and the cloud, right? And the different iterations between them. Then we're going to go and talk about Windows Azure virtual machines. So we're going to look at what is the offering that we have for virtual machines. And then we're going to look specifically at SQL Server running in Windows Azure virtual machines. And finally, we have some best practices associated with that. So we'll talk about all those things.
Okay. Well, I understand that SQL Server runs in all kinds of places, in on-prem, in the cloud, and all that. And you have a good way of describing it. Can you tell us in more detail?
Sure. So let's talk about the SQL Server Cloud Continuum. So in this graphic, basically, you can see all the different iterations that we have today and how customers are utilizing SQL Server, right? So SQL Server today is the most database used in the planet. And we have different ways of how people are using it. So on the left bottom side, you see physical. So many people are still running SQL Server on physical machines using the machines themselves. And that has been, traditionally how people have been running them. Over the past few years, we have seen many more people virtualizing SQL Server. So people using Hyper-V, for example, right, where you can have a large number of SQL Server instances running in virtual machines as part of the same physical host. And people are doing that in order to reduce costs. So the more that you share the underlying infrastructure, the less cost that you have, because you're amortizing the cost across a large number of SQL servers and across a large number of databases. So that's why we see more people using that. At the bottom, you can see on the left side, you have high control, high maintenance, right? So if you, for example, run your SQL Server in physical machines, you probably have a large number of physical machines that you have to manage, right? And because of that, there is a cost associated with that. Whereas in the case of virtualizing, you reduce the number of physical machines, right? And that's how you amortize the cost. Now, in the middle, we have SQL Server in Windows Azure virtual machines, or as in the industry it is known, infrastructure as a service. And this is what we're going to be talking about today. And this basically means running your SQL servers in Windows Azure virtual machines. These are virtual machines that are hosted by the Windows Azure infrastructure, right? So in this case, the main difference is that the host machines, the actual physical hardware, is managed by Windows Azure, and that means that you don't have to manage it, right? You don't need to go and buy new hardware. For example, if you have some applications that you need to host, you can simply host them in these virtual machines, right? And Windows Azure is going to take care of them. And we'll talk about in more detail what exactly Windows Azure provides as part of the offering. Then after that, you move one more step into what we call platform as a service. And here the difference is that from the platform, instead of having access to a virtual machine, you have access to a database. So the level of abstraction changes from the virtual machine into a single database. And the difference here is that because we're virtualizing the databases, right, and the actual official name for this is Windows Azure SQL Database. In this case, we virtualize the database. We take care of many of the maintenance operations associated with that database. But at the same time, the level of control that you have is lower because basically you have access to the database, but you don't have access to underlying maintenance operations. So we'll talk a little bit more about that in detail. And finally, on the top, we have software as a service, and this is when you can access an application directly offered as a service in Windows Azure. And so examples of these are, for example, Office 365, where you can access directly the Office application, right? And you don't have to think about how the data is stored. So you don't really have the concept of database at that point. Right? So this is basically the continuum, and this is how we see customers using the SQL Server across the different platforms.
So we're going to focus on the one that is in the center, right? The IIS SQL Server in virtual machine. You're going to describe to us in more details, right?
Right, absolutely. So it's going to talk about Windows Azure virtual machines first, and then we'll talk about SQL Server running in Windows Azure. So what exactly Windows Azure virtual machine means? All this means virtual machines that are hosted on the Windows Azure infrastructure. We offer multiple virtual machine images that you can use to provision virtual machines, and I'll show you that in a demo. We have images, for example, for SQL Server, for Windows Server, etc. And you can provision virtual machines out of those. You can bring your own images. So you can, for example, take a VHD of one virtual machine, and then you can upload that VHD to Windows Azure, and you can provision multiple virtual machines out of that VHD. Provisioning is really fast. It's 10 minutes right now, and that's from the time that you start the process to the time that you have a virtual machine running with SQL Server. Your virtual machines are accessible in different ways. You can access them to remote desktop, for example, just as traditionally you use any SQL Server in your own environment. You can use PowerShell, for example, as well. All the information for your virtual machine is accessible through the portal. We'll look at that. And also you have some REST API. So for people who are using REST, for example, they can use that to gather information about their virtual machines as well. We offer pay per usage. So basically, you only pay for the time that you use the virtual machine. So, and we do this at the minute, by the minute. So we don't round up. Basically, you only pay for every minute that you use the virtual machine. The moment that you don't need the virtual machine, you can stop it, for example, right? And if the virtual machine is not running, you're not going to pay for that. Right? The cost of the virtual machine depends on a couple of factors. It depends on the size of the virtual machine. So you have different sizes that go from what we call extra small, which is 1 core, for example, and having 1 gigabyte of RAM to we have very different sizes, right? And it can go all the way to 8 cores, for example, and 56 gigabytes of RAM. So depending on the size of the virtual machine, you pay some price per minute. And also there is some cost associated with licensing. So for example, if you use a virtual machine from an image that has SQL Server, there will be some cost associated per minute with that, right? And again, we have different versions of SQL, like Enterprise or Standard or Web Edition, and the cost will depend on that.
So when I turn it off, for example, I will not get billed for that for the usage since I'm not using it. So I turn it off, but I'm still paying for the storage.
Correct. So you stop the machine. We still keep the storage accessible for you. So in the case that you want to restart the virtual machine, right? You don't have to go and recreate it again. So you will only pay for that storage, which is a very, very small amount. Something else to mention for people who have MSDN subscriptions, we have large discounts. So if you go into the Windows Azure portal site, you will find more about it. But again, very, very interesting offering. In terms of network, you don't pay for data that you send into Windows Azure. So if you're uploading, for example, a large multi-terabyte database into Windows Azure, you're not paying for that. You only pay for the outgoing cost.
I see.
So that's how it works. As we mentioned, storage, you only pay for what you use, not what you allocate. So for example, if you have 1 virtual machine and you allocate, let's say, 5 terabytes of data, and you're only using 1 terabyte, you only pay for that terabyte. You don't pay for the other 4. Right? So you can start over provisioning, thinking about the future, and you only pay for what you use. Elasticity, a very powerful concept. It's very easy to go and change the size of your virtual machine. You can do this through the portal, for example, and it takes a couple of minutes, and you can go from, again, a very small virtual machine to a very large virtual machine, right? So from 1 core and 2 gigabytes of RAM to 8 cores and 56 gigabytes of RAM. We're always introducing new sizes, so as time progresses, you'll see more RAM and more cores available. Okay. Finally, again, you have high level of control, similar to how you do it on premise. But at the same time, that means that you have some responsibilities in that virtual machine. So in the same way as you today manage your virtual machines on premise, you will manage them in Windows Azure, and that means you're in charge of security, for example, who can access that virtual machine, those Windows accounts, for example. You're in charge of patching the operating system in that virtual machine, and monitoring as well. Right? So I think it's important before talking about SQL Server, how is the storage managed in Windows Azure. So every disk that these virtual machines have attached ends in what we call Azure storage. And Azure storage is basically a cluster dedicated to store all the data for Windows Azure, right? So you have thousands of disks that we can use as basically shared storage across all of these virtual machines. Azure storage provides high availability for all the data, and this is based on 3 synchronous local copies. So what this means is for every disk, Windows Azure Storage will maintain 3 copies, right? And these are synchronous. What this means is for some reason one of these copies fails, because for example there is a corruption in one of these disks, we can automatically redirect those reads and writes to another copy of the disk, right? And all of this is transparent to the virtual machine, right? So it's very highly available from the client perspective. We also have the option of 3 more asynchronous copies in a different data center. And this is if you turn on an option called geo-replication. And what geo-replication does is we asynchronously copy that disk to 3 more copies in a different data center. And again, this is for disaster recovery purposes. Okay. So in worst case scenario where a full Windows Azure data center becomes unavailable for some reason, we can go and recreate all those virtual machines in a different data center and continue running.
So by default, 3 distinct local copies are there,
right? But
the remote copies is optional.
It's optional. You specify it in the portal.
Okay.
All right. In terms of availability, so the first SLA is you'll never lose data. So Windows Azure guarantees, again, to these 3 copies, that data will always be available. That's super important for SQL Server. If the virtual machine becomes unavailable, right, because, for example, the host machine fails, or because there is some network problem, Windows Azure will automatically restart the virtual machine in a different host. Okay. It will move the virtual machine. And the way this works is we have all this storage in Windows Azure Storage, right? So if the virtual machine fails, we can just attach that storage, right, as disks to a different virtual machine and continue running. Okay. So again, it's a transparent process from the customer perspective. We have an SLA today, and the SLA is based on having multiple virtual machines in what is called an availability set. So the availability set is a concept, and I'll show you this in the demo. It's a concept in Windows Azure where if you put 2 or more virtual machines in the availability set, you're telling Windows Azure to locate those virtual machines in different hosts and in different racks. And the idea is that if for some reason there is a failure even at the rack level, right? For example, the rack loses connectivity, you'll still have 1 or more virtual machines in different racks that are available, right? So the SLA is 99.95%, and that means that you're going to have less than 22 minutes of downtime per month, right? That means that at most 22 minutes, you're not going to have neither of these virtual machines accessible, right? And we'll talk about with SQL Server specifically if you require even higher levels of availability, right? If you're looking, for example, at 2 nines or even more than that, right. How can you achieve that with SQL Server? In terms of this availability, this SLA, it includes a couple of things. It includes planned downtime. So every month, Windows Azure refreshes the host, right? So all of those virtual machines are running in some host machines, and we refresh the operating system. We make sure that it has every security update, for example. And also unplanned downtime due to physical failures. So again, virtual machines may be impacted, for example, because a host fails. So all of that is covered by this SLA. right? It doesn't include the servicing of the guest OS. So similarly to on-premise, you still need to patch Windows, for example, in those virtual machines.
Okay.
Right? Windows Azure, again, provides support for disaster recovery. So worst case scenario, if Windows Azure becomes unavailable, we have a different data center where we can restart these machines. The maximum estimated data loss that we have right now is 30 minutes. Again, this is in case of a disaster. So far, we haven't had one of them. And then virtual machines will be online in less than 24 hours.
Right.
So all information about availability. Let's talk a little bit more about high availability. Again, important from the SQL Server perspective, and how this works in general for Windows Azure. So what you have in the screen is a rack, right? This is one of the racks that we have in Windows Azure. You have different physical machines, right? Each of these physical machines has virtual machines, right? How many depends on the sizes of the virtual machines. And then in the middle, you see that it has what we call the top of rack, which is basically the connection from that rack to the rest of the world, right? So all the connectivity goes there, all the power goes there, and then it distributes to the different machines. And then we have many of these in a data center in Windows Azure, right? Now we have this concept of availability set. So if you put your virtual machines in an availability set, what will happen is that these virtual machines will end up in different racks, right?
Physical racks.
Physical racks.
Okay.
So the way you can achieve high availability is by locating a load balancer between your clients and your virtual machines, right? So if you put a load balancer, and the way you do this is that you put these virtual machines in what is called the load balance set. Again, it's a concept in the portal. We'll look into that. And by putting this load balancer, all the requests are going to be load balanced between the different virtual machines, right? In case that one of these racks becomes unavailable, right, you will still have the other virtual machines to continue running. Right? So that's how you can ensure transparent availability for your clients.
Okay.
Right?
Awesome.
All right, let's talk a little bit about connectivity. So once you have these virtual machines running in Windows Azure, how can you connect to them? So we have two ways. The first one is you can connect to them over the internet, just using public endpoints. Again, the concept of endpoint is similar to the concept of, similar to the concept of ports, for example, in machines where you open the port and you can connect to that. So in the same way, in Windows Azure, you can create these endpoints. Basically, the endpoints will allow connections on the specific port, right? So if you have clients in your data center, for example, that's one way you can connect to them. Another way to connect to these virtual machines is using a site-to-site tunnel, right? And this site-to-site tunnel is basically a VPN tunnel, right? That allows you to extend your on-premise network into Windows Azure. So this tunnel will allow you to connect to all of those virtual machines in Windows Azure just as if they were part of your local domain. Right? So you can, for example, use your DNS server and you can refer to those virtual machines in Windows Azure through name and you can connect to them. The site-to-site tunnel will also allow you to join those virtual machines in Azure to your on-premise domain. It will allow you, for example, to extend all of those domain policies that you have, for example, how often passwords need to change into Windows Azure as well. A site-to-site tunnel is secure as well. So if you want to have, for example, an encrypted channel between on-premise and the cloud, you can use the tunnel for that as well. And there are different ways of how you can create a tunnel. You can configure a physical VPN device. So people who have Cisco VPN device, for example, they can go and configure that. And I'll show you again that in the demo soon. Another way of doing this is through Windows Server RAS, routing on remote access services. So with RAS, you can use software, for example, and then you can set up your tunnel using one of your machines in your corporate environment.
I see. So hardware or software solution?
Hardware or software solution, you can use any, and as you can establish this site-to-site tunnel. Again, just showing some of the options how customers can go and enable the site-to-site tunnel today. We have different brands available for physical devices. We talk about Windows Server RAS. We support even generic VPN devices, right? Even if they're not in this list. There are some of the conditions that they need to fulfill, so they need to be able to basically satisfy some of these algorithms for encryption and authentication, like AES 128, for example, or SHA-1. etc.
Okay, awesome. Well, this is very interesting. Can I see the portal and see how you configure?
Sure. So let's look into the portal. Let's have a quick tour. So what I have here is the Windows Azure management portal. So let me make sure that people can see the address there. manage.windowsazure.com. That's where you go to Windows Azure. So use a quick tour. Basically, on the left side, we have all the different services that are offered by Windows Azure. Right? So you can create websites, for example. We'll have virtual machines, and this is where we're going to be spending most of the time today. But there are other things that you can do. Mobile services, for example. SQL database. Again, this is the PaaS offering, right? Platform as a service, where you get access to your SQL database. Information about storage. So you can create what is called storage accounts. You can store what is called blobs, binary large objects. So this is basically where you can store all the disks associated with your virtual machines. Right? And then we have many other things. I will spend a little bit more time talking about networks. Right? Networks is an important concept, and this is how you can enable, for example, the site-to-site tunnel. So we'll look into that as well. And other things like Active Directory, for example, for people who are using Active Directory today. So right now, what you can see in the screen is all the set of virtual machines that I have. You can see the name, the status. You can see most of them are running. I stopped one because I wasn't using it. I didn't want to pay for that, so I stopped it.
Okay.
You can see the subscription. So as part of one account, right, you can have multiple subscriptions. And this is how you can assign, for example, management operations to different people, right? So with a single account, you can create 3 or 4 more subscriptions, and then different IT administrators, for example, can have access to different subscriptions, and each of the subscriptions will have access to different number of virtual machines, for example.
Right.
The location, again, the location is where in the world these virtual machines are located. We have data centers in Central US, we have some in Europe, for example. We have some in Asia, and we'll look into that. And finally, the DNS name. And the DNS name is the name that people can use over the internet to connect to these virtual machines.
Okay.
Right? Again, you can specify you want to allow this by creating the endpoints, or you can close the endpoints, and then you can only access this through the tunnel.
Right.
Now let's go and see how can we go and create a new virtual machine. So I go into New, right? Click New, and then you see again all the services. I go into Compute, right? Virtual machine. I can go into Quick Create, which basically just presents me a quick page here, and I can just fill a couple of values and then create the virtual machine. But let's make it a little bit more descriptive. Go through the gallery, see how it works. So if I click on the gallery, you'll see all the images that we have available for customers, right? So if you click into Microsoft, you'll see all the images that Microsoft has available, right? So you'll see, for example, we have some images for Windows, right? You have SharePoint, for example, and then we have SQL Server, right? In the case of SQL Server, let's look at all the images that we have. So we have, for example, SQL Server 2014 CTP2 already, right? Okay. So something interesting, the same day when we released CTP2, we already had the image available, and that's something that we'll continue doing, right? So the moment that we release the RTM version of SQL 2014, in the same day it will be available here, right? Okay. And people will be able to use it.
So they don't need to actually painfully download and install it themselves.
Exactly.
They can actually do it in here.
Exactly. They can go directly to the image gallery and in 10 minutes download the virtual machine and provision the virtual machine and start using it without having to download. Right? Something that you'll notice is we have different versions of Windows. So we know that some customers want to use still Windows 2012 because they don't want to change, for example, the operating system. So we still have it. But we also have 2012 R2, right? For people who want to use the latest versions. We have, you'll notice that we have something called data warehousing, right? So for both 2014 and 2012, we have this edition called data warehousing. And it's basically an image that has been optimized for data warehousing. So we have set up many of the default settings by default, optimized for data warehousing. Again, so things like amount of memory assigned to SQL Server, number of disks, the configuration of the disk, all of that thing has been already optimized for data warehousing. Again, we have 2012 SP1, and we even go all the way to 2008 R2. right? So people who today have applications, for example, running in 2008 or 2, and they want to decommission some of these machines, or they just need a larger virtual machine, for example, because they have more customers now, they can go and utilize one of these images.
Okay,
right?
awesome.
So let's go and provision one of these. So I'm going to use SQL 2014 CTP2. Right, so I click next here. It'll tell me what version I want to use. I'll just use the latest version, right? Some customers want to maintain a previous version because they want to ensure that they have all the versions running in the same.
Okay.
But in this case, I'm going to use the last one. I'm going to give some name here. So Alberga's virtual machine, and then some name. I can choose the size of the virtual machine. Again, this goes from extra small, right? Where you have basically one core, which may or may not be shared with other extra small virtual machines, to A7, where you have 8 cores. And again, the amount of RAM changes between the machines. So for now, let me use a medium, for example, 2 cores, 3.5 gigabytes. This is small for now. I give it a name to my administrator, right? So I'm going to say L. Vargas is my administrator. I specify a password. All right. And then click next. Now, cloud service. So the cloud service, you can have a description just hovering there. It's a container for one or more virtual machines. So imagine this as a container for your 2-tier or 3-tier application, or a container for your set of virtual machines. So you can host all of these virtual machines in the same cloud service, and then some of the management operations will apply to all of them. So it's easier to.
It's a logical grouping.
It's like a logical grouping mechanism.
Yeah. Okay.
Right? This is the DNS name that I'll use to connect over the cloud. You see the suffix is cloudapp.net.
Okay.
Right? Again, what subscription I want to use for this one. So I'm going to use this one, the manual subscription. And I have some other subscriptions, so I'll just use this one. Where do I want to locate it? So you can see I have different regions, right? I have some in Central US, East US, West Europe. At the subscription level, you can specify the regions that will be accessible. So for example, right now, the administrator of my subscription, I think didn't give me the option of West US, but that's another data center that we have accessible. So let's say I want to locate it in Central US. Storage account, again, you may already have some storage accounts that you use to manage all the storage, right? All the disks, for example. If I don't have one, or I use a new one, I just say create a new one, right? Availability set, we talked about this concept before. I'll show it in the next demo. Again, this is ensuring that these virtual machines are going to be in different racks. In this case, this is only my first virtual machine, so this doesn't apply. So I click next. Now I can specify what endpoints I'm going to make accessible from my virtual machine. By default, I have remote desktop, right? So I can remote desktop to my machine. I have PowerShell as well, so I can use remote PowerShell, for example, if I want to. I can go and add one more. So I can say I want to use SQL Server endpoint, and what this is going to do is create an endpoint allowing connections on port 4033, which is the default SQL connection port. Right? So at this point, I can go and say complete, right? And then it's going to go and run for some time, right? Again, it's around 10 minutes. So I'm going to let this run. It's going to run for a while. In the meantime, let me go and show you something about networks. Okay. So let's click into networks. If I click in networks, I'm going to see all the networks that I have associated with my subscription. So you'll see, for example, some of these networks. Where do I have it here? So yeah, some of these networks are to Central US, some of them are to West US, etc. The interesting thing here is if I click on one of these, for example, this one, you'll see that this is a network in the cloud only, right? You see this is basically specifying the name of the network. I can see the virtual machines that I have as part of that network. You can create subnets, right? So in this case, I have, for example, a domain controller running in this subnet, and then I have the rest of the machines running in a different subnet. Now, the interesting thing is I can create these site-to-site tunnels that I told before. So in this case, this network is one of those. And I can see that because I have this graphic representation where on one hand, I have Windows Azure, right? And I have the Windows Azure gateway. And on the other hand, I have my on-premise environment, right? And these are connected through the VPN. Right? So the interesting thing here is that through this virtual network, I can refer to all of these virtual machines, as well as my on-premise machines using my on-premise DNS servers. And the network gives information about how much data goes inside of Windows Azure, how much data goes outside, information about the IP address that my on-premise environment uses to connect to. And then I can look at all the virtual machines that are part of this virtual network, right? And again, I can refer to all of these virtual machines using the name that I give to the virtual machine, even from my on-premise environment. Right? So very powerful capability for my domain environment. So let's move on into the next rest of the slide.
Yeah, let's talk about more detail for SQL Server that's running inside these virtual machines.
All right. So let's jump into SQL Server. So as we talk about, we have many SQL versions supported. We talk about SQL 2014, 2012, R2. Again, many versions of Windows supported. One of the very, very powerful capabilities is we have almost 100% compatibility with on-premise. The only reason why I said almost is because we don't support yet SQL clusters. That is something that is coming later. But the rest of the application surface is supported. The consideration, as we described before, this is in a virtual machine, so you're in charge of managing security for SQL Server, backups, high availability, etc.
Right.
What are the scenarios that customers are using for SQL Server in Windows Azure? We have three scenarios. The first one is dev and test. So many people want to build and test new applications, right? And they want to use the latest versions of SQL Server. So they can very easily go, and in 10 minutes you have a latest version of SQL running, and you can develop a new application, you can test it. Lift and shift. So customers want to move an existing application to Azure. So they can do this without any changes, right? They can simply move the database to SQL Server Windows Azure and continue running. Again, we support multiple versions of SQL and Windows, so whatever version you are using on-premise, you can go and use it there. Whenever you need it, so some customers, for example, have some periods when they need higher processing power, for example, or larger amounts of memory. So during those periods, they can move it, for example, to Windows Azure and run the application there.
Got it.
And then, again, this is an elastic offering, so you can start, for example, with a small or extra small machine, and then once you complete the application and you decide to go into production, you can move into a large or an extra large machine, for example. Have the flexibility, and again, it's very easy to change in the portal. And finally, we have some customers that are actually using hybrid scenarios. And in these cases, part of the application is still on-premise. So for example, they have the application, like the clients running on-premise, connecting through A.NET, for example, and they have SQL Server running in the cloud, right? And they connect them through the site-to-site tunnel. That's an example. You can have Active Directory, for example, on-premise, and you can use Windows authentication to authenticate to those SQL servers running in Windows Azure. Another scenario that we see people using are having SQL servers running on-premise and then adding replicas of SQL Server in Windows Azure virtual machines. And they use this, for example, for disaster recovery, where if the main data center goes down, they still have one or more copies of those SQL servers running in Windows Azure that they can use. The other thing is they can use those SQL Server replicas, for example, to move some of those reporting workloads or backups into Windows Azure, right? So people, for example, that need to maintain backups outside of the main data center, they could put a replica in Windows Azure and take the backups there. How do you go and deploy these virtual machines with SQL Server? Well, there are two ways. As we talk about, you can use the gallery image, right? And this comes with some predefined options, for example, for memory settings. This image is going to include the engine, the SQL Server engine, integration services, reporting services, analysis services, and management studio, right? So you can use all of these services and utilities. We refresh the image every month, so every CU, every critical hotfix, for example, is already included as part of the CUs, right? At the point of provisioning. The other option is you can bring your own image, right? So people or customers are familiar with the concept of software assurance. So if you have your licenses on premise, you can use what is called license mobility, and then you can use those licenses in Windows Azure as well. And the way it works is you prepare your BHT, right, from your on-premise virtual machines, and then you can upload that BHT into Windows Azure, and then you can provision virtual machines from them. Right? Another option that we have in SQL Server 2014 is the deployment wizard. This is a wizard that we introduced in Management Studio, and you can use this to very easily move a database from on-premise into Windows Azure. So the way this works is the wizard takes a backup of your database to a network share, and then we copy this backup to Windows Azure storage, and then we provision a new virtual machine, or you can select an existing virtual machine, and we restore the backup in that virtual machine.
Oh, okay.
So, and the wizard will basically, in case that there is some network connectivity, because you lose connectivity to Azure, and you're trying to move a large database, for example, it will go and retry, so you don't have to start from the beginning. So something very important, this wizard can be used with previous versions. So if you download, for example, Management Studio for SQL 2014, you can use this wizard with previous versions of SQL Server, 2012, 2008, etc.
Wow, this is very interesting. Are you going to show us how it works?
Yes, so I'm going to show you. Well, we're running a little bit out of time, so what I'm going to show you is actually a deployment that I have running with multiple SQL servers in Windows Azure already. I have an application, so let me show you. That's probably more interesting for people to see once they have everything running there. So let me go again into my virtual machines here. Right. So what I'm going to do is just search for the ones that I'm going to be using in the demo. So if I choose Contoso, basically this is going to show me these SQL servers that I'm going to be using. So right now I'm going to be using these three. Right? So the interesting thing here is you see I have something called Contoso Quorum. So what I have here is a SQL Server configuration that has two replicas. Right? This is using Always On. Okay. This is a high availability solution for SQL Server. And I have a primary and a secondary. I have a witness. Again, this is for automatic failover. But what I wanted to show is if I click on one of these, so let me click here, you'll get more information about your virtual machine. So you'll get, for example, information about the CPU utilization, disk utilization for reads and writes, network, etc. This virtual machine is a large virtual machine. You can see here it has 4 cores, 7 gigabytes of RAM. And what I wanted to show is if I go and look into configure, you'll see the concept of the availability set that we talked about before. So I have created this availability set called SQL HA. I have put my 3 virtual machines as part of that. And again, this ensures they're in different racks. And then I configure high availability between them. So to show this, I'm going to connect to the virtual machine. Right. So again, this is the virtual machine that is running in the cloud. You can see the domain suffix at the top here, right? cloud.dpp.net. And then I can see that I have my SQL Server here, right? Installed by default. I can see everything exactly as I do on premise. So I have my databases, my tables, everything there. Exactly the same interface as we have on premise. So I can go and say, use this particular database, right? And then I can go and select from my table. And I know this is super simple, but basically what this is showing is all the skills that you have today for SQL Server apply 100% here.
So it's full feature.
Full feature, right? So you can see I have, everything that you can look at in SQL Server. I have views. I have all the things in programmability, full support for stored procedures, triggers, rules, etc. Even features like service block, everything is accessible here.
Okay.
SQL 14, things like in-memory databases, what we call Hackathon is available here as well.
Okay.
So everything is accessible here. Even high availability. So if we go here, for example, for people who want to guarantee that SQL Server is running at all times, right? Even if, for example, the virtual machine has to be restarted, they can go and configure availability groups, right? So you'll see here, for example, that I have an availability group that I have configured here, right? And again, this is running between my 2 SQL servers in my virtual machines, right? So I have this one that I'm running as a primary, and I have the one running as the secondary. So what this will ensure is that even if the virtual machine goes down, the availability group will automatically fail over my SQL Server, and this takes around 10 seconds. So that means that worst case scenario, I'll have 10 seconds of downtime, and I'll continue running.
Okay.
So people who are running production workloads that require high availability, they can go and do this as well. So very, very important capability. So basically what you have seen so far is highly available SQL Server configuration running on Windows Azure.
Right.
Right?
Okay.
So
maybe we can use the rest of the time to talk about some best practices that you see from customer deployment.
Yeah. So let's actually do that. We have 7 minutes. Let's talk about some of the best practices that we recommend to people to use when they run SQL Server in Windows Azure machines. So let's talk about high availability first. We just show always on configure for these SQL servers. Again, the reasons why we recommend people is if you want to have failure detection for SQL Server, the failure detection that Windows Azure provides is at the virtual machine level. So it will detect if the virtual machine is not running, for example, but it won't see inside of the virtual machine. Obviously, for privacy reasons, we don't see inside. So if you want to detect failures because SQL Server, for example, is the service is down or it's running out of memory, you can configure a SQL Server high availability technology. Right. Again, the other reason is if your application can't stand the recovery times for restarting the virtual machine in different hosts, which today takes around 12 minutes, then you can configure your high availability technology, right? And it takes, again, 10 seconds.
Right.
Recommendations. So when you go and create these replicas, put them in the same affinity group. Again, this is a concept in Windows Azure. Right? When I provision, you can specify the affinity group, and this specifies to use the same cluster, right? And you want these replicas in the same cluster to reduce latency between them.
Okay.
Same availability set. This ensures different racks, and same VNet. Putting these virtual machines in the same VNet guarantees that they can connect to the name at all times. This is because the IP addresses of those virtual machines never change.
Right.
Right? So this avoids having to update DNS entries, for example, so you can always connect to the names. And finally, you can use these secondary replicas for something else than just waiting for a failover. You can use it, for example, to move some of those read workloads. You can use it to backups. Something very powerful that you can do is you can actually load balance reads across these readable secondaries. So if you have some reporting applications, for example, that require very fast response time, and you have a very large number of users, you can, for example, add 2 replicas, right? And then you can have load balancing of the reads between them.
Okay.
This is basically what this picture is showing. So in your availability group, for example, in Windows Azure, you can have your primary and multiple secondaries, and then you can use these secondaries for failover, right? And your applications, your OLTP applications, will find the primary to something called the listener. The listener is just a DNS name, right? And that's how they always connect to the primary. They don't need to find it. The listener will find it for the applications, and then you can have reporting applications, for example, connecting to your readable secondaries, right? And you can have a load balancer between them. So very powerful configurations that you can go and build today if you want. Let's talk about connectivity, some of the best practices. So if you don't use some of the endpoints, you probably want to remove them. Again, this is just general security best practice. If you're not using some ports, for example, just close them, right? And you can do that when you provision the machines through the portal. There is a capability called endpoint ACLing, so you can specify which are the IP addresses or subnets that can connect to specific endpoints. So you can control access to those endpoints. Obviously, don't disable Windows Firewall. Windows Firewall is enabled by default. Don't disable. You can always open the specific ports that you need. If your clients are in Windows Azure, host them in the same virtual network as SQL Server. Again, this will ensure that the IP addresses never change.
Right.
They can always connect to the name. If you need Windows authentication to authenticate to SQL Server, you can either configure a domain controller, right, in Windows Azure, or you can set up a site-to-site tunnel between on-premise and the cloud and use your on-premise domain controller. If you don't use it, then you can simply use SQL authentication. Right? Security best practices, we have Windows Update enabled by default, right? So we recommend not to disable it. That's how we ensure that all the security hotfixes are available on the guest OS. For critical SQL Server updates, people may want to turn on Microsoft Update, right? We recommend not using the account name administrator just because it's a well-known account, so people may want to use something else, right? By default in the portal, this account is disabled, so you have to name it something else. We recommend people using a strong password, again. when you provision the virtual machine, the local administrator that you specify in the portal becomes the SQL sysadmin. That's the account that you can use to manage SQL Server. In some companies, they want to have the separation between the administrator of the virtual machine and the administrator of the SQL Server.
Right.
So if that's the case, you can go and change this. And finally, for your clients, you can enable database connection encryption, and you can interact and encrypt the channel between your application and SQL Server.
Right.
Especially important if you're using public endpoints over the internet.
Right.
In terms of performance, I'm going to go quickly here. Actually, in the next session, we're going to go into detail in performance. So, couple of things. If your database fits in 1 terabyte, very easy. Just create a single data drive, and you put it there. The data drive has a limit of 1 terabyte. You can have 16 drives, or 16 terabytes maximum. If your database doesn't fit in 1 terabyte, what you can do is you can stripe the data files across multiple disks.
Right. Okay.
Similar to what you do on-premise today. By striping, you also get larger IOPS limits, right? So there is a limit on the number of IOPS per disk, and that's 500. If you need more, then you can stripe again, and you get 500 per disk, right? Use database compression, again, just to reduce the amount of I/O that you do in the system. Use Windows Instant File Initialization. Again, this is enabled by default. And this is basically to reduce backup times, right? Finally, something to consider is we have this storage system, which is separated from the virtual machines, and this is to ensure that we never lose data, and this is why we have 3 copies. But at the same time, that means that there's going to be some network latency between the virtual machines and the storage. And because of that, latencies may be higher than what you have, for example, with a local attached disk. So we're going to go into a little bit more detail in the next session about performance. We have a lot of resources available online. So the first place to go is the SQL Server in Windows Azure Virtual Machines documentation. So the link is in the screen. So from there, we provide all the best practices. We provide all the information about pricing, as well as some of the offers that we have, for example, with MSDN.
Awesome. Thank you, Luis. So everyone, thank you so much for watching this session. We're going to be taking a quick break, and we'll be starting in the top of the hour again. Thank you.
Thank you, Remy. Thank you.
Welcome back, everyone. This is Darmadi Como. I'm very happy to have Shin with me today. Talk to you about SQL Server running inside Windows Azure Virtual Machines. We're going to focus more on the performance tuning portion today. So Shin, why don't you talk about the agenda and then where you're from and all that?
Sure. Thanks, Darmadi. My name is Shin, and I'm a program manager on the SQL Server team. I have been mainly involved in the performance aspect of the running SQL in Windows Azure Virtual Machines. So today, I'll be happy to walk us through some of the key topics in the troubleshooting, as well as the performance tuning of running SQL in Windows Azure. So without further ado, let's just get started. The key things that we want to cover today mainly includes that we want to make sure that everyone is aware what are the key considerations in terms of performance when running your SQL in this new environment, basically the Windows Azure Virtual Machines, as well as share with you some of the best practices and lessons learned throughout this whole process, before we bring Windows Azure Virtual Machines to GA, as well as this whole past year. And last but not least, of course, because we have very limited access to the machine and also, the back-end troubleshooting tools, we want to also share some of the key things that you can also arm yourself with in terms of, how to actually leverage the whole environment when you're, using some of the key things that in here.
So in terms of the performance, what are the key considerations that typically we want to consider?
Yeah, especially with the Windows Azure Virtual Machines, people feel like, this is not a typical on-prem environment that they're familiar with because they don't actually have access to the hardware anymore. So what would be different is that, they still, as usual, they need to consider what are the things like, whether this is a problem with my SQL Server application, or this is because of the environment that I'm, not really configuring it the best way. And of course, when you're doing that, it is really worthwhile to put in the effort to first define some of the key performance indicators. Basically, we see two things coming to mind. One is your throughput, and the other, of course, is your latency. Or, when you're putting in the context of your workload, it comes into, what's the response time that my user would be able to observe. So there are, of course, multiple dimensions in that aspect as well. For instance, you would have OLTP workload, which is, typically just 8K in size, and it's random reads or writes. And also there are, of course, also data warehousing workloads. They're much bigger in size and also mostly sequential. And also backup workloads, how it is going to behave in this new environment. So basically you see things like, IO size, and also whether they're random, they're sequential, all these bundled up together. You need to kind of, pivot them differently to be able to understand it better.
I see. So Windows Azure Virtual Machine has many sizes, right? So you have different sizes. What are the sizes that you can talk about, and what are the performance implications?
Absolutely. So actually, we have this just coming up. The key thing that we need to, as we mentioned, is that, you don't have the exact same environment as you are used to when you're on-prem. For instance, you may have very beefy machine on your, on-prem world where you could have, a socket or even more. But in this Windows Azure environment, we have very limited sizes. But of course, we're growing and also increasing the size limit for our VM. But in here, this lists out the currently available sizes that we have in the Windows Azure virtual machines. So basically, it goes from extra small, where the CPU is shared, like half a core, all the way up to A7, where we have 8 cores and 56 gig of memory. As you see, this part, it also has a dimension of how many disks that you would have access to. That also is appropriate depending on the VM size that you have. For instance, the A7 has up to 16 disks that you can attach to, and a single disk can be up to 1 terabyte in size. The last column I do want to zoom in here is that it means, how much IOPS that you can actually expect. So this is already a limit that the Windows Azure is enforcing. It means that it's an upper limit, per disk you would be able to, get to. But, it's not a minimum size that it's guaranteed. So this is useful when you're doing your, VM sizing as well as, provisioning, capacity provisioning exercises.
Okay, it's very interesting because SQL Server is very I/O heavy and all that stuff. Can we actually peek inside the I/O subsystem that Windows Azure provides?
Sure. So when we're talking about the Windows Azure I/O, it's important to understand, first of all, the architecture of it. So different from the on-prem world where the directly attached disks, you have very low latency because it's local. And here, it's different because it's all network connected storage. And also the backend storage, okay, we have something in here. So in here, the difference is that in your guest OS, you don't directly access when you're writing your I/O, it doesn't go through the NIC. Actually, it goes through the hypervisor and then share the host OS network. And also important is that every writes and also every a piece of data is actually triple redundant. It's already built in the Windows Azure backend storage. So when you're thinking about it, it's always a trade-off between your high availability, the data redundancy, as well as your data performance. So that also sheds some light into how you think about the storage. So if we want to look at more closely, Windows Azure also offers 3 different disk types. One is that it has OS disk. It has a fixed size of up to 127 gig. And also it has data disks. And the number of disks, as we mentioned, it depends on what VM size that you have. So in here, it can be, for extra large VM, you have up to 16 disks. And apart from that, we have a volume D, which we also call the temporary local disk. But different from the two other other disks that we already talked about, the OS and also the data disk, is that this temporary local disk is not persistent. What it means is that whenever there is a maintenance or healing event, like if the VM crashes, then this disk space basically just goes away. And whatever data that you put on there, you won't be able to see it again. So that's why when we're actually running SQL applications, we would always recommend our customers to stay away, not use the temporary disk for storing any of your data.
Got it. How about caching portion of things, and what's the best practice that you can show us?
Yep. So when we're talking about caching, we need to be a bit careful because there are multiple caching that comes into mind. In here, specifically, we're talking about the Windows Azure Virtual Machine disk caching, and it is actually a two-tier caching. Of course, as all the caching mechanism, is anticipated. It's to actually, kind of shortcut some of the data that you don't have to go to the back end, which is the Windows Azure storage, so that you can leverage the local storage. In here, you can leverage two-tier. One is your RAM cache, and also the other is your local hard disks. But you have to be aware is that, the RAM cache, of course, it caches your most recently used data. The local hard disk cache, on the other hand, although it's local, meaning that it has lower latency, but it does have a limited IOPS because it is just basically hard disk kind of, striped over across multiple disks. So it is, really confined in size in that sense. And in terms of disk caching configurations, we do see that, they vary depending on which disk we're talking about. So that's first, take the temporary disk out of the picture because it is not actually implemented as a VHD, so it's really not applicable for it. As to the OS disk and also data disk, that we see that the default caching mode out of the box, it's actually different between the two. For instance, for the OS disk, you will see that the default mode is actually read-write, and also for data disk, actually out of the box, you will see that none. Basically, you don't have the read or write caching enabled in that case. This basically is because for OS we want to gain that extra mile in terms of boot performance, so that's why it's set in this way. So this is basically how it differs between the two. And in terms of best practices, we want to make sure that for SQL Server we leverage the best of the two worlds. So for instance, for really small database workloads, we can actually, say that you start with your OS disk and run your workload there. Basically, that means, very minimal and changes to a workload. So it's simple and also, suffice in terms of, mostly small workloads. Small, we mean, smaller than 10 GB. But on the other hand, if your workload is much bigger, and also it is really intensive in the I/O operations, we would of course recommend that you stay away from the OS disk and use data disks instead. So in that case, depending on your workload profile, for instance, if it is really read heavy and you really want high IOPS, and that means you would better off to actually go with, not go with adding caching. Just the default setting would be just great working for you. So out of the box, disable caching for really I/O-intensive workload so that you get high IOPS. But on the other hand, if your workload really doesn't really stress that much on the IOPS, but you would want, on the other hand, to get some of the lower latency benefits, you may actually want to test out, just enabling the read caching to be able to see if that gives you some of the extra benefit. For SQL workloads, typically we do write through. So that's why, enabling or disabling the write cache typically doesn't really impact us. So that's the key thing that, I want to make sure that we bring up.
Yeah. There's also single or multiple database configurations. Can you describe more how do we configure those?
Yep. So as we already see the dimension of that last column when we're describing the VM sizes, we see that, per disk level, you're already seeing that 500 IOPS limit is already in effect. So that's why when we're doing the disk configuration and testing, as well as for sizing your workload, you would really want to take that into consideration. So for instance, if your workload is lower in terms of IOPS requirements, you can just start with a single data disk, that profile, that works fine. But as your workload grows, you may not see that being sufficient. So that's why you would be able to see that you really need to actually add more disks to your workload. And in that case, you would also have options. For instance, you can actually do a couple things. One is that you can just use the database, use the file groups to actually distribute your database files across multiple disks evenly, and that way you can kind of stripe them across. That's one. Option two is that you can also just create a single volume across multiple disks that you have attached. So that a lot of times we see people do it because they want to ease the management experience. They want to say, I just want to have a single database, a single volume to work with. That can be a good option for you too. But we have to be careful in here is that even for this option, you can actually do it two ways. One is that you just use the OS volume to just use the Windows OS to actually striping that. The other way is that you can use the storage spaces actually. This is actually based on our testing a recommended approach because we see that the performance difference between using the SQL file, file striping and also the storage spaces is very, very trivial. And this is actually giving you the best performance in terms of using a single volume. Otherwise, you're just better off with using the file striping with SQL. So this is our recommendation.
So lots of information to talk about doing this thing. You're going to show us the demo today, right? On how to measure performance on the disk.
So today I actually just want to showcase a single demo. But even before that, actually, we can actually start by just taking a look at some of the, for instance, in here, I have a SQL IO instance running. So the way that it's set up is that I have a test file. This test file, I want to make sure that people understand what it does. Basically, this is a random read workload because it denotes that it is random. And also it runs about 300 seconds. And at the same time, we have 32 outstanding IO, and this is 8K in size.
So this is a good tool to test the performance of the disk.
Yes, this has been the tool that we've been recommending to our customers for years. So you have been actually using it already for on-prem, even measuring your performance. And in this new environment, basically you can still do it. And the way that we also recommend customers do it is that you can actually write it also to an output file. This would actually give you the benefits that when you're doing it, you can actually keep your results. So for instance, if I want to go to my virtual machine, I can do it. So this brings up all my VMs. And the way you want to do it, that you want to actually monitor your performance on an ongoing basis. And then in this way that you can see that basically I have my VMs created. And you can also see the disk configurations. So it needs to take a little while, and that's just get back first to see the results of our SQL IO running. So basically this gives the IO of over 6,000, and this translates into 12 megabytes per second in terms of throughput.
Okay.
Over time, actually, you can also plot those results just so that you can have a baseline for your monitoring. And this gives you an indication as to, when you're seeing your perf trending going up or down, you can get a sense, where problems can actually arise. Okay, my presentation.
So while Shin is trying to get the things up, there are many ways to actually get the performance up on the disk perspective. And when we talk about the disk, right, you have the caching portion. You also have the disk configuration portion. Next, actually, Shin's going to show us in terms of the networking. How's the best practice on the networking portion to speed up the disk as well, right? And then also the TempDB, the disk compression in terms of the I/O also, we can also do that as well. So why don't we switch over to my desktop here to start talking about the next portion of the best practices. Shin?
Okay. So the next part is about the network performance. So we talk about I/O a lot of times, but on the other hand, what we have to be aware is also that network-wise, it also can be a not bottleneck. For instance, one concept that Windows Azure introduces is the affinity group. It basically ensures that you can co-locate your resources so that you can actually shortcut some of the network latency that you don't have to actually come across when you're bundling your cloud service together. So this is an important concept that we recommend to our customers because you would want to actually ensure that shorten your network latency, especially for your chatty network applications when they're bouncing back and forth. You don't actually see that just keep on growing and becomes a real problem for you. And at the same time, within your virtual network, you would want to actually use your virtual IP, internal IP addresses to be able to address each other. And if you really have, for instance, an always-on workload, you can even be a bit more creative. Think of, how to load balance between the always-on availability groups, using, for instance, the public IP addresses to just, especially for the read workloads, to really, go load balancing between them.
Okay, this is cool. So there's other things that we can speed it up in terms of the disk on SQL Server as well. Maybe you can talk about that as well, right?
Sure. So TempDB is already one thing that we mentioned. So this thing we really don't recommend our customers going on D drive. So whether the short answer or the no answer, the long answer is no. You don't want to put your data on TempDB. Why is that? First of all, you would actually go. People would say, I can actually just recreate my folder for my TempDB. Wouldn't that actually work? Well, that can work, but on the other hand, you would still be able to just, you have to actually work across many of the hurdles. On the other hand, if your TempDB, for instance, it can be a bottleneck for you. In that case, you would really want to partition it out, split them into multiple files. But for that, of course, you wouldn't be able to do with a single disk. So that's why you really want to actually leverage the data disks that you attach, and then you can just split multiple, between the multiple disks to be able to just partition out your TempDB as well. So that's why, we want to say just to stay away from the D drive, even for your TempDB.
Okay.
And the other one that is pretty obvious is that, typically you get really good mileage from enabling the data compression. This becomes even more relevant in the world of Windows Azure Virtual Machines. Why? It is because, we actually see that reduce a lot of the network traffic and also the I/O as well. So that's why you would really want to enable that option to be able to identify what is the table that, actually you can leverage the most for this option to enable the data compression. For instance, we have in this, slide, we have side-by-side two types of workloads. One is the OLTP, and the other is like a typical data warehousing query. For both cases, you see that the throughput actually just significantly has grown. But on the other hand, we do want to point out that your CPU usage may actually grow as well. So just take into consideration of that and make sure that it's a balanced option. Depending on which dimension that you want to get the most of, you really think about the data compression option as well.
Okay. How about the file initialization?
This is also actually one of the lessons learned that we have. We have seen that in the Windows Azure virtual machine environment, anything that associated with like, creating a DB, restoring a DB, and also adding files or extending files, those operations can be very, very expensive. So enabling the instant file initialization is really a key step in here. You can see the significant difference between with and without them. So really make sure that you use it, and as to how, we actually have a slide, in the appendix later that we can share with the user, as to how they can step-by-step configure it correctly. But this is really the key. But make sure that you, this is not something that you cannot really leverage for your transaction log, because basically this is only applicable for your data files.
Okay. Any other things that we can consider?
So more lessons we also summarized in our white paper, the performance white paper. We also have a link later in these slides. But basically, we take into multiple dimensions into account, like when we're doing the testing. Even the warm-up effect, we also test it out. What it means is that we observe that when you have first created a virtual machine, attach the disks, and before you actually run your workloads, then measure them and do things like, you want to benchmark them, you would really want to kind of, run some test workload, like synthetic workloads to be able to just, expand the disk a little bit to kind of giving it a warm-up effect. That usually takes about, 20 minutes. So that's why when you just directly run your workloads on this virtual machine, you may not see your best results just out of the box, because it takes a little bit time to actually get to, a ramp up and to a really stable and also, a good state. And conversely, we also see an effect of, cooling down. So for instance, if you don't really use your VMs over time, and what we see is that, your performance started to get kind of, getting to a lower state. It is because that you, in the Windows Azure virtual machines, in the backend storage, they have a partition layer, which is kind of a mapping where your actual data is. So if you don't use your data enough, that means that, the pages start to get collapsed together, and then you really don't get that fan out, kind of effect to scale out, your reads or writes. So that's why over time, you want to really make sure that you consider that both the warm up and also the cool down effect as well.
Okay. Well, thanks. So you covered a lot of the things on performance, a lot of information on the disk portion, the caching portion, the I/O portion, and even show us the demo of it. So let's say if I already have this running and it's all fine, configured perfectly. How about in terms of maintenance, in terms of monitoring and make sure that it always continues to run well, right? So can you share with us more on that?
Absolutely. So performance monitoring, as we just briefly touched upon, it is important really first to actually establish a baseline. So for instance, using the tool as I was showing you, the SQL I/O, you can actually choose the different I/O sizes. For instance, you can have 8K depending on what workloads that you are testing out. Use it, and also make sure that you write the outputs in a file, so that you can actually keep monitoring on an ongoing basis. That is an important kind of first step you want to take. And some of the other tools that you want to leverage, you can actually see, for instance, in the Windows Azure Virtual Machine portal, you also see the dashboard. It gives you a really kind of a crisp and also very high, level overview as to, what's your resource consumption in terms of, especially the CPU, as well as, how much I/O that you're generating. And even further, you can also see, you can actually enable the storage analytics, which is also a more detailed tool that actually captures every single I/O that you have issued and what's the experience of that, so that when the team actually doing the troubleshooting, they can actually grab that file and make sure that they can analyze that as well.
Okay. So let's go through more of the monitoring tools perspective. I see you have screenshots as well.
Yep. So this is one example, as we mentioned in the dashboard. So it gives you as to how much activity has been going on in the system. The storage analytics, on the other hand, you need to make sure that you enable that in the portal in the configure tab when you actually go into your virtual machine. So this actually just tracks all your blobs and also tables, all the queues, operations. And for instance, it has the server kind of time and also the end-to-end time, so that they can actually rule out what is the bottleneck of my performance, whether it is actually in the network or it is actually more like, in the storage layer. This is also one key thing that, when you're actually escalating, through our CSS, our support team would be actually also requiring and asking for this piece of information. And also, absolutely, performance counters, as always, we have been asking our customers to leverage, so that you can see in much more detail as to within your VM, what is the I/O, how are they actually responding, what's the response time. You can actually also identify a lot of more bottlenecks through that as well.
Okay, so you talk about the monitoring portion of it, and how do we monitor, making sure that it's okay using the tools that we talk about in Azure.
Yep.
How about if I find out that something is wrong? How do I start troubleshooting? Is there any best practice steps that you can talk about?
Sure. So in terms of troubleshooting, we have, a lot of the cases where in the on-prem world, people are already familiar with, like the steps that you would say, basically it forms into identify the bottlenecks and then just, put forward some of the resolutions. Some of the typical kind of, factors are, if you have the plan change, and also if you have, just bottleneck on your hardware that you identify. For instance, your I/O subsystem is just not keeping up. Typically those aspects, we have very exhaustive guidance for customers for on-prem as well already. But what we want to take, if we move to the next one, we can see that, in this new world, one key thing also still there is that you would want to incorporate the definition of your KPIs into this step, especially when we're dealing with Windows Azure Virtual Machine, and especially when we don't have direct access to the host machine to a lot of the key performance indicators there, or counters either. So for instance, if we go further, we would see some of the examples that we can actually guide our customers to see what are the typical indicators of issues, and what are some of the resolution or mitigations that you can take. Be mindful, of course, that this environment, you have limited access or limited, resolutions, or kind of, what you can, weapons, in your, that you can actually have. For instance, if you really see that CPU being a bottleneck, and after all the typical troubleshooting and the things that you can do, an option may be just you have to scale up, meaning that you have to go for a larger VM size. And if you actually identify some of the other issues in your I/O subsystem, well, this is the part that you really don't have any other kind of scale up option, not just yet, but in future we actually have enhancements in terms of we have much lower response time and latency I/O subsystem coming along, but all the resolutions you would have to really see what you can do with the current situation.
Right.
Yeah.
So can you do a quick summary on what we talked about and what's the additional resources that they have?
Sure. So basically, in this session today, we actually walked us, basically through the same structure as we actually outlined in the performance white paper. This is something that we have published, last June. We highly recommend our customers to go and check it out, especially when we're talking about those lessons learned and best practices. They're exhaustively, just being summarized in this white paper, and even some of the tools and examples, like the SQL I/O. How do you use that, and how do you actually kind of leverage that for your ongoing performance monitoring? They all have been given examples and summarized in the appendix. So that is important. The second thing is that remember that Windows Azure Virtual Machine, it is a cloud environment. So inherently, you would see performance difference as well as the variability. So that is why it is really, really critical for you to have the necessary tooling to be able to monitor and also to be able to identify the key bottlenecks of your performance. Just making sure that you have that kind of baselining is already important. And the other thing, of course, you would have different VM sizes to choose from, and also the difference in terms of the I/O subsystem. But all those comes into what this new environment is about. Follow your traditional steps that you have already known, you're familiar with. Basically, largely they all still apply, but some of them are even more important in this new environment than in the traditional on-prem, especially like instant file initialization, and as well as using the page compression for some of the key hot tables in your system. Those become even more critical for this new environment. So those are the key things that we want to make sure comes across in this session.
Okay, great. Thank you so much, Shin.
Thank you.
Thank you. I'm just going to show you guys the white paper itself. So we're going to continue this conversation today. We'll take a break about 15 minutes, and we'll be able to come back and show you guys about data warehousing as well as the business intelligence workload. How is it running inside SQL Server virtual machine as well in Windows Azure? Okay, thank you so much, guys, for watching.
Thank you.
Hello everyone, welcome. My name is John Huang, I'm your host, and I'm a program manager at Microsoft. I'm very pleased to have with me Torsten Graf from the SQL Server engineering team to discuss the data warehouse workload for the Azure VM. For the next 45 minutes, we'll do a quick introduction, and then we'll provide an overview of the data warehouse market and Microsoft data warehouse offerings. We'll provision the new data warehouse VM, and also, finally, we'll share the data migration best practices. So let's get started. Again, my name is John Huang. I'm a senior programmer with the SQL Server Azure CAT team since 2008, working on the MPP appliance solution for the large-scale workload. I have over 20 years experience in providing software solutions for manufacturing, retail, and healthcare industry. I'm currently focusing on the persistent data storage solution for the on-premise, cloud, and the hybrid scenario. And Torsten?
Hello, everyone. My name is Torsten Graf. I'm also a program manager here at Microsoft. It's great to be here today. I've been with the SQL Server team since 2004 in various roles in development and program management. I'm currently working on modern data warehousing workloads in the cloud, and Elastic Scale for SQL Azure DB. Previously, I've worked in areas such as query notifications, XML optimizations in SQL Server, and some data warehousing work as well.
Okay, great. So, Torsten, as you know, Microsoft made great investment in offering the full spectrum of data warehouse products for various workloads. Could you share with us some of the current product offerings that we have?
Yeah, let's take a quick look into what is out there. And I've structured it into two parts. So you see on the left side of this slide, you see our on-premise offerings, and on the right-hand side, you see our cloud-based offerings in Azure. And let me start at the bottom. So our on-premise offerings for data warehousing include SQL Server Enterprise Edition, and specifically Enterprise Edition because it comes with a lot of the data warehousing-related features. Also for big data customers that want to do some compute or semi-structured data processing, we have the Windows distribution for Hadoop, which I'm showing here. That's the HTTP part. And then if you go to the upper left-hand corner, you see our appliance-based offerings. And there we have two offerings in the market. The first one is the SQL Server Parallel Data Warehouse Appliance, which comes with the Poly-based technology that allows you to integrate between the relational processing on one side and the Hadoop-based semi-structured data processing on the other side. So that's a scale-out, shared nothing parallel data warehouse appliance. Also, we offer an SMP appliance, which is called Fast Track, with a number of different hardware vendors that's SQL Server based on the Enterprise Edition again. Now let's jump over into the right part of this slide, which is our offerings in Azure in the Microsoft Cloud today. Again, starting at the bottom, you'll see that we already released general-purpose SQL Server images in Azure VMs, and those are ready for any general-purpose SQL Server deployments. And we also have the HD Insight service for any kind of big data processing in our cloud. Now, what we're going to focus on today is what you see in the upper right-hand quadrant of this slide, which are the appliance-like optimized VM images for the data warehousing workload. And that's based on the SQL Server general-purpose images that we have in Azure. But those images are specifically tuned and optimized for data warehousing as a workload. let me show you a little bit how this fits into the bigger picture of our different offerings on-premise and cloud, and what the characteristics are that you have for these different offerings. So looking at this slide, on the left side, you basically have our on-premise offerings, SQL Server. You as a customer own the physical hardware, the machines on which you run SQL Server, run your data warehouse. That gives you the highest control over what you do on those machines, and the highest control also over the specific configuration. However, you're not benefiting from any of the cloud cost benefits. So once you've acquired the hardware, you're stuck with it, and you need to keep running it. One step further then is the red part that you see here on the slide, which is basically using virtualization and a private cloud, and you can run SQL Server on VMs in your own private cloud, and also use appliances like the Parallel Data Warehouse appliance or the Fast Track appliances. That gives you a little bit less control over what you do because some aspects are pre-configured. However, you still own the underlying hardware. The next step in this progression here is jumping into the cloud and using Windows Azure infrastructure as a service, using virtual machines in Azure for your SQL Server workloads. And that's the green part that you see here on the slide. And that still gives you quite a bit of control because you can pretty much configure and manage the SQL Server instances that are running on your virtual machines in Azure. Now, taking the last step here on this slide, it takes you into the platform as a service offerings with Azure SQL DB, where a lot of the management aspects for your database are being taken care of automatically by the platform. And that's where you probably give up most of the control, but you're also sharing a lot of the infrastructure and the underlying hardware with other customers, so you're getting the best cost benefit in that area. The focus for us today is on the green part, the infrastructure as a service virtual machines, and specifically the ones that we have tuned and optimized for data warehousing so that you get an appliance-like experience when you deploy them in Azure.
So could you go into a little more detail about the value proposition of this new VM data warehouse? And how's it different from the other VM that we have out there, images that we have out there?
Yeah, happy to. That's a great question. So here you see in one big picture, the different offerings that we have around VM images for data warehousing. The first one is for SQL Server 2012, and the other one is for SQL Server 2014 CTP2. They have a couple of parts in common. They're both based on Enterprise Edition. They're both using Windows Server 2012. And both of them have been optimized using the Fast Track optimizations and the Fast Track best practices that we already used to tune and optimize appliances, data warehousing appliances for on-premise workloads. We've basically just taken those learnings and best practices and applied it to Azure and our VMs in the cloud. Both of them give you the ability to attach up to 16 terabyte of disks with the A7 or the XL VM sizes. So those are the parts that are in common between the two different images that we have in the Azure Gallery. Now let's talk a little bit about the differences between these two VMs. So for the SQL Server 2012 VM, it's obviously based on the SQL 2012 image, and we are recommending that for a VM size A6 with 5 Azure disks. That's the configuration where we have gotten the best performance with the Fast Track optimizations and the Fast Track workload. So that's what we have been optimizing for SQL Server 2012. And it can take you up to data warehouse sizes of up to 400 gigabytes in data size. And that's up to this size, you stay within the Fast Track best practices. Obviously, you can accommodate much larger data sizes, but then you are no longer in the sweet spot from a Fast Track perspective. Now let's talk a little bit about the SQL Server 2014 VM image as well. Obviously, it's based on the SQL Server 2014 CTP2 bits. We are recommending that for the A7 VM size and with up to 9 Azure disks. And this can take you up to 1 terabyte in terms of data warehouse sizes, and you're still up to 1 terabyte within the Fast Track configuration and Fast Track best practices. The reason for the difference in the data size between these two images is that SQL Server 2014 comes with a number of important features for data warehousing. First of all, I want to mention the cluster column store index, which is new in SQL Server 2014, and it allows you to compress your data warehouse and keep it in memory. That's also the reason why we decided to go with the A7 VM, which has the larger memory size for the SQL Server 2014. If you're using cluster column store index, you can fit most of your data warehouse into main memory, and it gives you much better performance, particularly in Azure. There are a couple of other features as well that are important from a data warehousing perspective that I want to mention in this context for SQL Server 2014, and that's incremental statistics for partition tables, and also a new cardinality estimation framework that we have put into the product. Both of them work very well and are designed for data warehousing workloads. So those are, in a nutshell, the two different offerings that you will find in the Windows Azure gallery.
Okay, so next, I think a person is going to demo on how to provision the VM.
Yeah, let's do that.
Right.
Let's jump into Internet Explorer. And I'm logged into my Windows Azure subscription here. And you see a couple of virtual machines that I've already provisioned. But let's start from scratch and actually go and set up a new virtual machine from the Azure gallery. And it takes me into this dialog where I can choose an image. Let's narrow down on the SQL Server images. And what you see here are different SQL Server images. Here's the one for data warehousing for SQL Server 2014. And here is the one for SQL Server 2012, again, optimized for data warehousing. So those are the two images that we have in the gallery that are optimized for data warehousing. Let's take the one for SQL Server 2012 and take the A6 offering, put me in as a user. Let's use an existing cloud service for this. Let's use my existing storage account for this. And let's go with the defaults for all the other options, including the ones here. And let's finish this dialog. And you can see that I have a new VM that's in the provisioning phase right now. It's called GG Demo. And it will take a couple of minutes to stand up that virtual machine for us. So why don't we jump back into the presentation while we wait for this to finish, and talk a little bit about the highlights of these virtual machines. What are you getting? What is the configuration in more detail? So one of the key benefits that I really want to call out is that for those virtual machines, they're 100% compatible with the functionality and the surface area for SQL Server on-premise. So whatever you've done already for your on-premise offerings, functionally, it's the same for those virtual machines. Obviously, you're running those virtual machines in the cloud. So based on that, you may see some differences in performance because you're sharing the infrastructure with other cloud customers. One key benefit of these virtual machines is we have tried to make the deployment and the provisioning process as simple as possible for you. And there are two ways that you can do that, and I'll explain those in a little bit more detail. For right now, just keep in mind there's one way that basically takes you all the way through the Azure portal to deploy and configure those virtual machines. The other one allows you to deploy them in a fully automated way through PowerShell. And that's a great way for those that need to provision a large number of these virtual machines. You can automate that process by basically crafting your own PowerShell scripts to stand up those virtual machines for data warehousing. So let's take a little bit of time to discuss the different configuration options and the kind of tuning that we have done for those virtual machine images. So based on the fast track best practices and guidance, there's a number of startup options for SQL Server and also trace flags that are recommended for data warehousing workloads. And we have basically automated the configuration of SQL Server such that those configuration options are automatically being taken care of for you. So for instance, just to give a couple of examples, we are using the -E startup option for SQL Server, and we're also using a trace flag 1117 as pre-configured option on the instance. The memory settings are also optimized based on fast track guidance. We are reserving 92% of the available memory in the virtual machine. That's typically where you see the best performance for relational data warehousing workloads. In addition to that, we have also taken great care of provisioning your I/O subsystem to the extent that this is possible in a virtualized environment like the cloud. So we are using storage spaces to abstract from the underlying Azure disks, and we are basically putting the Azure disks that you provision under storage spaces, and then we are laying down the database files on the storage spaces disks. That makes managing your I/O system, your disks, much easier because there's just a single point that you need to go to, which is the storage spaces. The sizing that we've talked about, like the 400 gigabytes for the A6 and SQL 2012 and 1 terabyte for SQL 2014, that's based on the fast track guidance where we hit the sweet spot between CPU power that we have on the virtual machine and the I/O subsystem, the Azure disks that we've attached to the virtual machines. Once you provision the disks and the VMs, then we have an automated tool that's running in the background and basically waiting for the disks to show up for the VMs, and I'll show how that looks like. And then once the disks are available, it will automatically create the storage space for it, put down the data and the log files, and optimize that database file placement on the disks and the storage spaces. I mentioned that there are a couple of different ways how you can provision your data warehousing VMs. The first one is the portal-based approach, and that's what you've just seen in the little demo that I showed. And it's a great way for first-time users to just learn about the product and get guidance through the provisioning process. And all of those interactions actually can be done through the portal. So if you're just new to this space, then that's a great way for you to get started. And if you look into the little animation or the little picture that I have on the slide here, basically you pick the gallery image, and if you are the portal-based users, you go through the portal provisioning process for the actual VM. That's what I just showed in the demo. Then the next step for you, and you can do that through the portal as well, is attaching the disks for your VM. And once the disks are provisioned for your VM, then our automated configuration kicks in, and it takes a couple of minutes. And after the configuration is complete, you have a fully optimized, fully tuned SQL Server VM for data warehousing. Now, if you need to do this a couple of times, you will find it cumbersome to go and click through the portal UI for every VM that you want to stand up. If that's the case, then you can use the PowerShell approach, which is particularly appealing if you have repeat deployments. It's completely scripted. We have a script available in the Azure Script Center, and here's a link on the slides that you can follow that takes you to the scripts. And the script is leveraging the image that we've put into the Azure Gallery, and it also automates the disk provisioning process. So if you look into the picture on the slide here, it basically takes the gallery image and provisions the VM and also automatically attaches the disks to it. And then our configuration background process picks up and produces the fully optimized, fully tuned data warehousing image. So obviously, the scripted approach, it's a script that's publicly available. You can tweak it and tune it according to your specific needs.
So it's likely that your image that you just provisioned is probably complete right now. So I believe that the next demo you're going to show us is how to add the disk.
Yeah, let's do that. Let's take a quick look and see whether the VM is ready. It doesn't look like that, so it probably is going to take a couple more minutes for that VM to complete, which is fine. I've already provisioned an image here, which you see down here, which is up and running. Let's connect to this real quick to see what's going on. So here's our first login, basically, into a freshly provisioned data warehousing VM. And it brings up it brings up the MSDN page that tells you precisely how to finalize the configuration and the optimization. As I mentioned, the only step that you need to do is to add Azure disks to your VM. And the page that will automatically pop up when you log in explains this in detail for you. One thing to keep in mind is that in order to stay within the fast track of best practices, we are very, very carefully looking at the amount of memory that's available in the CPU that's available on the VMs. So you will see that different VM sizes expect different numbers of disks to be attached. So that's something to be mindful of if you go into the portal to do that. So let's do this real quick for this virtual machine that I have here. And note that I use an A6 VM size. So this VM expects 5 disks, 5 Azure disks to be attached to finalize the configuration. So the way that you would do this through the portal is to attach an empty disk down here from the attached disk dialog. And the size that you need to use for the data warehousing images is 1023 gigabytes. Set the host caching preferences to none, just to make sure that you have durability for the transactions that you do. And now for the A6 VM that we're working with here right now, you would basically need to go through this dialog 5 times to attach the 5 disks. That can be quite cumbersome. So let me show you a way how you can actually do this much more quickly. And the way to do that is to go into Windows Azure PowerShell. What I've done here is I've added my Azure account so that I can run PowerShell commands against my Azure subscription. I've registered my subscription, Windows Azure internal consumption in my storage account, and let's try to connect to this VM that's out there and running. And this seems to have worked. So let's look at the VM. So this is the VM that we just connected to. It's called ggdemo raw. Has no disks attached. And now let me go and take a couple of these commands here, and we'll look at them in just a second, and plug them into the PowerShell window here. And you saw them just fly by. Look at this one up here. So basically what it says is I want to add an Azure data disk, a new one with 1023 gigabytes in size, host caching disabled, and then a couple of labels and parameters for it, and attach this disk, add this disk to the VM that we just got in this variable. So, and I've basically issued 5 of these add disk commands for that VM. And they're waiting to get deployed. So let's deploy them. And the great thing about this is that you can actually do this in one shot. So basically get all the get all the disks provisioned.
With using the PowerShell, is it doing it in sequential order, or is it adding all 5 disks in parallel?
No, the great thing about PowerShell is that it's actually adding all of these disks in parallel. And that gives you much better performance also as compared to doing it through the Azure portal, because in the Azure portal, you can obviously just do one at a time.
Right.
Here, you're doing all 5 of them in one shot.
Great. That's great. Saves us a lot of time. Right?
Yep. And what I've seen by just basically working with it, it can take you easily 10, 15 minutes to do that in the portal.
Right.
Here, it usually completes within a minute or 2 for all the disks.
Great.
And it's independent of the number of disks. So if you would go for an even larger VM size, so let's say for an A7, where you have to attach 9 disks, this is really a great way to speed up this process of attaching disks. Okay, great. So you see that the process just finished. So all the disks should be attached now. That puts the VM in a place, in a position where our automation for the configuration can pick up.
Right.
And it will run in the background for a couple of minutes to provision and tune SQL Server for data warehousing. Let's keep the VM running for a couple of minutes to complete that optimization process. And then we'll log into the machine again and see what's been going on. Let's do that.
Right.
Let's minimize some of those windows here.
So while we have the VM configuration running in the background, Torsten is going to discuss about what some of the options of migrating the on-premise data into this Azure VM that we just provisioned.
Yeah, and that's really a key question that we have seen with a lot of customers, and particularly for smaller data warehouses or data marts. They find it very attractive to use the cloud for their data marts, in particular if they just need to run that data mart periodically or for just a couple of days to run queries or to run reports. So the key question here is, how do I get my data mart, my data warehouse from on-premise typically into Azure, into the cloud? And there are a couple of different options that we have looked into to find out what's the best way to do that. And it starts with just SQL Server Integration Services, which is a great tool to do these kind of things. Also, there is the ability to back up and restore a database using a URL as the backup device. That's another very simple option that you can use. And then there are a couple of tools out there that are really helpful in this particular context. One of them is Azure Copy. Obviously, what you can do is you can back up your data warehouse on-premise and then take the backup files and copy them into the cloud using Azure Copy. The other approach is that you create virtual disks through backup and restore, put your backups on those, and then either use Azure Copy to move the VHDs into the cloud, or you can actually ship the disks to Azure and have them mounted. The last approach, obviously, if you can afford to take your data warehouse offline for some time, is to detach your database files, copy them over into Azure, and then reattach them. One of the key factors that's governing your experience for the migration is how thick is your pipe between the place where you have your data warehouse, so typically your data center or on-premise server, and the cloud. And the speed or the bandwidth that you have to upload your backups or your VHDs, that will pretty much tell you how long it's going to take for you to do the migration. Now, obviously, it helps if you can shrink or minimize the amount of data that you have to transfer. So think again about using a couple of great tools that will help you to keep the size of your databases under control. Again, thinking of SQL Server 2014, column store indexes are a great way to reduce the amount of data through the compression that you get with the column store index. Another step that you can take is truncating your logs before you go through the migration process, or shrinking your database files before you do a detach and attach migration. So those are some of the things that you can take to reduce the amount of time that you spend on the wire transmitting the data from on-premise into the cloud. So let's look at a performance comparison between some of these different approaches. So what I've put together on this slide here is for two data warehouse sizes, one with 100 gigabytes, the other one with 1 terabyte. I'm comparing the performance of the different approaches that we just discussed. So one of them is backup and restore through a URL device. The next one is backup and restore using VHDs and using AZ Copy to move the VHDs over into the cloud. And then backup and restore with just files, again using AZ Copy. And the last one, the purple one, is AZ Copy with detach and attach. And you see that all of them are more or less in the same ballpark if you're dealing with smaller data warehouse sizes. So it really doesn't matter that much. If simplicity is a concern for you and you want to minimize the number of steps that you have to go through and your data warehouse is pretty small, you really think about using the backup and restore with a URL device, because it's a very, very simple process. You basically just invoke the backup command, you point to the URL that you want to use, and then you restore from that URL into the data warehousing virtual machine. All of the other approaches require at least one more step, and that's a place where obviously exceptions or errors can occur. So if your data warehouse is small enough, think about using the backup and restore to URL. Now, if you look at the larger data warehouse sizes, we have a clear favorite, which is detach and attach in this case. But we are shrinking the database files for that. And be mindful when you do that, as it may introduce fragmentation to your databases.
So one of the things that stand out is that huge differences in the timing on the URL method for the 1 terabyte. Could you explain to us what causes the difference?
Yeah, that's a great question. We were surprised by that as well when we looked into this. And really the reason for that is that with the backup to URL command, excuse me, you can only configure one URL as the target device. And that basically puts you into a place where only one thread is writing into that single device. For all of the other approaches, in particular for the copy process, we're using multiple files that we could copy in parallel. And that option just does not exist as of now with backup and restore to URL. And it speeds up all of the other approaches quite dramatically. So that was something that really has helped us. And that's something that you should also think about when you migrate your data warehouse. Think about which parts of the migration process you can actually parallelize. In particular, when your data warehouse is big, it may help you really cut down the time that it takes for the migration. So based on that, really, for anything in the order of several hundreds of gigabytes in terms of data warehouse size, I would rule out the backup and restore to URL because it's just probably taking way too long for you. So think about using the other approaches instead.
Okay, so that's us to the next question is that, so I have several scenarios that I can migrate my data up there. Can you share some best practices on what scenario, what workload I can use each one of these methods?
Yeah, I'm happy to. And the split that we've come up with is structured around the size of your data warehouse. If your data warehouse is smaller than a gigabyte or has less than 1 million rows, then really think about using SQL Server integration services. It's very simple. It's very straightforward. In particular, if you're already familiar with integration services, I wouldn't bother learning a new tool if your data warehouse is small enough. Also, if at some point you have to move dimension tables that tend to be smaller, then SSIS integration services is a great option to do that. For larger data warehouses that are larger than 1 gigabyte but less than 10 gigabytes, as we discussed, the backup and restore through URL has actually acceptable performance, and it's a simple, straightforward 2-step process. So I would go with that if my data warehouse is less than 10 gigabytes. Now, for everything that's larger than 10 gigabytes, think about using detach and attach if you can take your data warehouse offline. If that's not an option for you, then go think about using backup and restore instead to minimize the offline periods. Also, try to truncate the logs in both of these cases. It will help you reduce the size of the data that you have to move across the wire. And consider shrinking your database files, particularly with detach-attach approach. Now, as mentioned previously, column store helps big time to reduce the overall amount of data that's persisted on disk through the compression that you get with the column store index. So I would recommend this for all the data warehouses out there. And so that's one place where compression really, really helps. Another place where you might think about compression is backup and restore using compressed backups. We have tried this option and found that it actually doesn't give you that much better performance. It increases the time that it takes to generate the backups in the first place quite a bit. But the savings, on the other hand, are pretty small. And that's particularly true if you're using the column store index with compression already. Then the additional compression that you're getting from a compressed backup is super small, and the additional time that you spend in the backup process to do the compression is not worth the benefits that you get in terms of the reduction of size. As mentioned, if you are going through the migration process, obviously the key factor on all of this is how large is the bandwidth that you have between the place where you've produced your backup files or where your database files live and the cloud. And if you can find a place where you have the best upload bandwidth, go with that place for the actual migration process, for the data movement process into the cloud.
Okay, so let's go back and check to see if we finished with the optimization process. Can you just basically show us what that new VM looks like?
Yeah, let's go back into Azure here. This was the VM that we went with.
Okay.
Let's connect to this guy. There we are, back again in the VM. Let's just bring up Explorer and see what has happened here. So what you see is, in addition to the regular SQL Server disks that you get with the vanilla SQL Server images, which are the disk drive C and the temporary storage drive D, you see two additional drives, drive F and drive G. The first one is about 4 terabytes in size. So 4 of the 5 Azure disks that we provisioned for that VM went into this F drive. And the fifth one, the 5th terabyte that we provisioned, went into the G drive. And in terms of the configuration, all the data files for your data warehouse should go into the F drive. And we have provisioned the G drive as the log drive for your data warehouse. Let's also look into Server Manager and see what has happened here. And look into the storage pools. And you should see that, basically the log drive and the data drive, they're showing up as storage spaces. And you can see that for the data drive, we actually have these 4 disks, these 4 physical Azure disks attached to that storage pool. And those are just 4 of the Azure disks that we just attached to that VM. And that's a great way for you to manage your storage. There's just one drive plus the log drive that you have to worry about, and you can manage everything through storage pools. We have also looked a little bit into the performance implications of using storage pools, and we have seen that it's about 10 to 15% in terms of a performance hit that the additional layer for storage pool adds in terms of latency. But we think that this is totally worth the little performance hit because the manageability benefits are much larger. So let's go and look into the actual SQL Server configuration and bring up SQL Server Management Studio and look at a couple of the configuration options that we've put in place for the SQL Server instance that's running on the machine. I was already telling you about the startup parameters and some of the trace flag settings and the memory settings that we're using. So let's take a quick look at that once Management Studio shows up. Okay, and so one of the additional benefits of using storage spaces while we're waiting for the Management Studio to show up is obviously that you can manage everything through the storage spaces console here. And just to complete the picture here, I was just showing the data drive previously. Let's take a quick look at the log drive. You see that the 5th Azure disk is actually used here as a physical disk to power the log drive.
So what are some of the performance number in terms of the network, the disk I/O, memory, CPU that we should be expecting working on this VM image?
Yeah, that's a great question. And obviously, a key factor here is that all of the disks, the physical disks that are attached to that VM are actually network disks that live in Azure storage. So for any physical I/O that you have to do, you are crossing the Azure network. And that has implications in terms of the latency, but particularly around the I/O bandwidth that you're going to get. And what we have seen in our performance evaluations is that for queries for read-only workloads, you're getting about 100 to 120 megabytes with these VMs that we have configured for query workloads. by just using the cluster column store index again, because more of your data will fit into main memory. Okay. The more data you can fit into main memory, the more physical I/O across the network you can avoid. Mm-hmm. So again, best practice: use cluster column store index for your data warehousing workload wherever you can.
Okay. Great.
So in terms of the CPU, we are just using the regular CPUs that you're getting on these virtual machines. So there are no real considerations or differences here as compared to a private cloud virtualized data warehouse. Okay. That's pretty much the same experience that we have seen there. Really, the key difference is around the physical I/O across the network. Okay. So let's take a quick look here at the configuration of the SQL Server instance on that virtual machine. You will see that the database settings are pre-configured so that the data goes to the mount point, the C drive, which basically points to the data drive in storage spaces. And the log is pre-configured to go to the mount point for the log drive in storage spaces. Mm-hmm. So when you create your database files, they will land in the right places on the disks that we have pre-provisioned for those VMs. So you don't have to worry about that. Also, I mentioned this, the other configuration setting is around the memory size, and here you see that we have configured the maximum server memory to 92% of the available physical memory in the machine. That's the setting here for the A6 that you see here. That's one of the settings that we have taken care of. Now let's fire up a query and do a DBCC trace status real quick. And trace status shows you the trace flag that I mentioned previously, the trace flag 1117, again, which goes back to the fast track best practices. Again, that's pre-configured for you so that you don't have to worry about that. Okay. So just to wrap up to what we see here, basically, in 15 or maybe 20 minutes, we have pretty much stood up a full-blown virtual machine tuned and optimized and configured for data warehousing with SQL Server. So if you think about the typical experience that customers used to have on-premise, that was quite a cumbersome process. Yes, yes. You first had to decide what's the hardware that you have to use for this. You had to purchase the hardware. Then you had to think carefully through what are the configuration options and what's the storage system that I want to put onto that machine. So all these questions are pretty much answered out of the box for our customers through those virtual machines in the Azure Gallery. So I've really done a lot of the heavy lifting around the provisioning process for data warehouses. We have done that for you through the Azure VM Gallery. And it's just, to me, it just feels like having an appliance in cloud. It's a very similar experience. All right.
So I think to wrap up is we have additional resources for you to take a look at. Please download this deck and then click on the following links there so you can learn a little more about all the data warehouse, the fast track, and IaaS images. And I think just to wrap up, I think that basically we have a few more minutes, so let's ask a few more Q&A questions. So I think that we have here. So one of the questions we have is that if I have data that do not fit into the 9 disk, and they just put additional disks, 10, 11, 12, and so on, can Data Warehouse IaaS handle it?
You can handle it. It's very similar to an appliance experience that you would have on premise. So think about getting an on-premise appliance. It comes basically pre-configured with a number of disks. Right. The same is true for our data warehouse optimized images in Azure. We expect a certain number of disks to be attached as part of the pre-configuration. Now, if you need more storage, you can go ahead and manually add additional disks to your VM. Obviously, the auto configuration will not pick them up, but you can go ahead and manually add them to storage spaces as additional physical disks, and then you'll benefit from the larger storage amount that you have to those additional disks. So you can do that. There are some manual steps involved into that at this point.
Okay. What about, can you attach existing disk VHD with the database data attached to the data warehouse VM?
You can attach them to the data warehouse VM. Nothing precludes that. However, what you need to be mindful of is if you attach these additional disks that have the VHDs on it, they will the database files will not live in storage spaces again. So if you want to basically put them into storage spaces, there are some manual steps, additional steps that you need to take care of in order to put them into the right place.
Okay. Okay. One more final questions. What's the upload speed that you see out there, and how do you handle the scenario where the client to the Azure data center bandwidth is narrow?
Well, that's a really tough spot. So what we have seen with our own evaluations was an upload speed around, or bandwidth around 60 megabytes per second. Now, we might be in a good place here at Microsoft, basically sitting in our labs. We might get a fairly good pipe to the Azure data centers. Now, if you have a substantially smaller pipe and less bandwidth for copying the data, one option that you can think of is actually shipping physical disks to Azure and have those physical disks with VHDs mounted as Azure disks for you. And if you have a large data warehouse and very little bandwidth, that might actually be the best option for you to get your data migrated. Okay.
So we are running out of time, and let's do a quick recap. So today we discussed the current offering of the Microsoft Data Warehouse stacks. We provisioned the Data Warehouse optimized VM, and also finally share the data migration best practices. On behalf of the Microsoft Virtual Academy team, Torsten, we thank you very much for watching and have a great day.
Thank you.
Thank you.
So, hi everybody, thank you for being with us today, or thank you for staying with us this morning. We're going to talk about BI workloads specifically in Windows Azure VMs today. So my name is Olivier Matrat. I'm a PM lead with the Azure CAD team. What the Azure CAD team does is essentially help customers develop and design and deploy analytics applications on the Azure platform. I've been doing that for a few years, and before that I was part of the engineering teams, and even before that I used to be a Microsoft partner. And I'm also a member of the PASS organization, which is an association of professional data experts. So with me today to talk about BI VMs in Azure is Chuck. Chuck, I'll let you introduce yourself.
Thank you. My name is Chuck Heinzelman. I am a senior program manager. I work for Olivier. As you can tell, senior is less than him. So yes, I am his minion.
No pressure.
Yeah, no pressure at all. I am also on the Azure Customer Advisory team. My focus is BI workloads in Azure infrastructure. I have been around the SQL Server community for over 10 years. Also involved with PASS quite a bit before I joined Microsoft. I had been a SQL Server MVP, and then I came and started working with this fine fellow here.
So you beat me.
I did. So I just want to go through the module overview. These are a few of the things that we're going to talk about here today. The first thing is I get to quiz my boss. And this doesn't happen very often, so I'm going to have a little bit of fun with it. We're going to talk about, are these different things part of the BI stack at Microsoft?
I thought you agreed that I was actually not going to work today, but that's fine.
No, I'm the one who doesn't work. You have to.
Okay, that's fine.
So then we're going to go into BI in IaaS with our gallery images. I know you've been hearing a lot about our IaaS stack, and we'll be talking a little bit about the gallery images there. Then we have the BI in IaaS without the gallery images. It's a little bit different. There's a few more options, and we'll be delving into that. So now we start with the quiz of Olivier.
Oh,
I think we need to move to my deck. Yep. Yes. Is this part of the BI stack? Okay. I'm going to ask you a bunch of different things, and we're going to see if you think that they are part of the BI stack. First one, analysis services.
So that's an easy one. Actually, I'm thinking you mean analysis services overall, meaning multidimensional models, meaning tabular models, even Power Pivot. That's
absolutely.
Okay, so absolutely it's a central piece of the BI stack, and so it's absolutely a part of what we want to talk about today.
I would agree with that. Yes, analysis services is part of our BI stack. It's been a core of it since 2000, back when we came out with the first version of OLAP services, yes, it is a key part of the BI stack.
That was easy.
How about the SQL Server engine?
So, arguably, it's not technically only BI, but it very often is part of the data warehousing or data mart solution that you put in place for a BI solution. So I would say definitely, yes, it's part of it.
Yeah, there are some situations where the only way to get at the data is from SQL Server, so tabular mode in direct query. The only way you can do that is with a SQL Server backend. So yeah, it becomes part of the BI stack. Reporting services.
So reporting services, again, there is many flavors of it. You can talk about operational reports. You can talk about reports against multidimensional databases. You can talk about Power View. So it doesn't technically have to be BI, but it can certainly be a big part, actually, of a BI solution. So yes, absolutely.
I would agree with this as well. It's when we came out with reporting services, in the 2003 timeframe. It was a groundbreaking release for us. We have advanced that quite a bit. So yeah, it is part of our stack.
Hey, how am I doing so far?
So far, so good, but the questions are about to get a little harder.
Ooh.
Active Directory.
So Active Directory. So that's a good one. As a BI practitioner, I would say it's not something that I would necessarily want to spend a lot of time on, but I would understand that someone needs to take care of it in the back end. So I would say it's part of the BI stack in the back end somewhere.
Okay. A little bit later, we will find out why I asked about that one specifically.
Okay.
How about SharePoint?
So SharePoint, we decided as a company to take a huge bet on SharePoint, and it was a paying bet, basically. Our entire BI stack basically has a dependency on SharePoint. It's how you share your insights, it's how you publish most of your reports, it's how you do alerts. So it's a central piece of most BI platforms. Yes.
I would agree with that, and one of the reasons I agree with it, we have shipped features in reporting services that you can only use when you're in SharePoint mode. The original version of Power View was only available in SharePoint mode. Alerting is only available in SharePoint mode. So yeah, we've basically built on top of SharePoint. Networking, and now I'm not talking about Facebook, Twitter. I'm not talking about social networking here. I'm talking about IP addresses, subnets, that type of networking.
So I'll tell you, that's something I would gladly let to my infrastructure guys. Again, I understand that you may need some of that in the back end. So why is it important?
I'll get to that.
Okay.
You're jumping ahead of me here.
Okay, that's fine.
Good taking the quiz so far, though.
Thank you.
How about Office?
So Office is the platform that we use mostly for our front end, for our BI platform. As you know, there's lots of BI advancements in the latest version of Excel, both on-prem and online in the cloud. So yes, Office is absolutely a crucial part of our BI platform.
And I would agree with all the statements that you've made so far. The reason I ask these questions, and the reason I specifically throw in things like Active Directory and networking and SharePoint, are that in the world of on-prem deployments, as a BI practitioner, even the IT pro space, you didn't necessarily have to deal with them. You just said to your IT staff, I need a SharePoint site to run BI, or I need a couple of VMs. In the world of Azure, that now becomes all part of what you need to think more hardly about. You need to think about networking. You need to think about Active Directory, because in your corporate world, you probably have all of that in place, and they just add you to the appropriate spot. In Azure, you're most likely starting with a clean slate. Unless you have some existing deployments, you are probably starting with nothing in Azure. So you don't need to know everything there is to know about Active Directory or networking or the Windows operating system as a BI practitioner. What you do need to know is enough to have that conversation and to be able to use our portal and use our tools to set that type of thing up.
So we really are talking about the infrastructure piece of the IaaS offering there.
Absolutely. We aren't. When I have done this presentation in long format at conferences, I've done things like spend 15, 20 minutes just talking specifically about the infrastructure pieces. We aren't going to go into that here. There's some great information on windowsazure.com about that if you want to go there and dig deeper. But know that there's more to doing this in Azure than just the BI stack.
All right, so I think I kind of passed the test, hopefully.
I think you did.
Thank you. I appreciate that. So maybe we want to actually do some real stuff right now, and maybe we want to actually jump into our first set of demos. I think we're going to talk about using VM images from the Azure portal, management portal, basically. And so you're going to walk us through all of that.
Exactly, exactly. So out in Azure, and I'm going to actually switch over to the Azure Management Portal right now, just to show you some of this stuff. In Azure, we have a series of gallery images. Now, those of you that have been watching all day have probably seen these already. Those of you that just came on to see the best presenters of the day probably haven't yet.
That'd be us, right?
Actually, they're after us, I think.
Oh, okay.
We're the opening act. So what we have in Azure is we have a bunch of gallery images, and these images are pre-made VMs, sometimes with just an OS, sometimes with software loaded, that you can use as a starting point to get going in Azure. And the ones we're talking about specifically today are the SQL Server gallery images. So you can come into the Azure portal or through PowerShell and actually create a image of SQL Server running in a version of Windows and be up and running in 10 to 15 minutes normally. It goes fairly quick.
So Chuck, can you tell us more about what's actually on those images? I mean, what kind of OSs do you get? What kind of versions of SQL Server do you get?
Yeah, you start off with the core OS. And the core OS has various flavors. Like, for example, on the screen here right now, you'll see that we have SQL 2014 CTP2 Evaluation Edition running on Windows Server 2012 R2. We have an Evaluation Edition of CTP2 running on Windows Server 2012. We have SQL 2012 running on Windows Server 2008 R2. We have a variety of OS and SQL Server combinations for you to choose from here.
So what if the variety or the particular version that I want is not in there? How do I do that?
I will get there a little bit later in this presentation.
Okay. Sounds great.
I already thought about that, and that's the next step of what we're going to do. But the first thing we're going to do is we're going to start with the gallery images, and I am going to postpone that. So I'm actually going to start with the gallery images, and we're going to talk a little bit about what is in them. And everything I'm talking about here today, just so you know, it's point-in-time specific. Azure is a world that is changing constantly. It's evolving. Things move very quickly in this world. So everything I'm saying is as of right now. Tomorrow it could change. But as of right now, and there is also specific to the SQL Server gallery images. These images come with a 127 gigabyte C drive. Not bad for a server image. You can get multiple SQL Server editions. Enterprise Edition, Standard Edition, even Web Edition in these gallery images. And that's your starting point. And as we talked about already, there's a variety of SQL Server versions, 2012, the CTP of 2014. It's all out there. Your storage options are based on the VM size that you use. We have a variety of VM sizes. They come in extra small to extra large, and then we have a few that are high memory SKUs that we call them, ranging in processing power from a shared core with 3/4 gigabyte of RAM up to 8 cores with 14 gig of RAM for the standard sizes. Then the extended memory sizes, we have a 4-core 28 gig machine, and we have an 8-core 56 gig machine. So you choose what's going to be right for your situation. Then how much data you can store with that machine depends on the size of the VM that you pick. For example, and this is all documented on windowsazure.com. I won't go into all the different configurations here, but if you choose an 8-core VM with 14 gig of RAM, you're going to be able to attach 16 VHDs to that machine. Those 16 VHDs, each one can be up to 1 terabyte in size. So with an 8-core VM, you can have 16 terabytes of storage attached to that server. We also come with some BI tools installed by default. We start off with analysis services in multi-dimensional mode and reporting services, in addition to the core SQL Server engine. That's there to start with. The reporting services native mode here is not configured. It's there, it's installed, but none of the configuration tasks have been run. And another important thing to point out here is this is pay-as-you-go licensing. You don't have to have the SQL Server license before you start this up. When you're charged for VMs in Azure, you're charged a base rate based on the operating system, and then in this case you get an upcharge for the SQL Server license. So it's all covered. You don't have to go out and purchase licenses. You don't have to do anything. You just spin up the machine and go with it.
And again, so if I wanted to have my own version of SQL Server or my own version of the operating system, I could do that as well, right?
Yes, you can, and we will get into that a little bit later.
Okay, sounds good. So I guess the next step is actually showing how you use those VMs and what you can do. You talked about configuring the reporting services instance, basically. So can we actually walk through that?
What we're going to do for this demo is it's one of the tasks that everyone who's done anything with BI has probably done hundreds of times. We're going to configure reporting services.
In my sleep.
Yeah, it's not the most interesting task in the world. But the reason I want to use it is because everyone that does this has done it. And I'm going to point out as we go along the differences between installing or configuring reporting services in Azure in a VM versus configuring it on-prem. So I really want you to see the difference.
Just a quick spoiler, lots of differences or few differences?
Hold that one.
All right, I'll wait.
All right. So the first thing that we're going to do is I have a VM that's up and running. And yes, I expected this to happen. I do have a few planned little errors in here. Periodically, as if you leave a VM, connection to a VM in Azure open through remote desktop long enough, it will eventually time out and it has to reestablish itself. Warning, it's a normal thing, it happens. Don't worry too much about it. It comes back fairly quickly, as you're about to see. So what we have to start with is a Windows Azure virtual machine using the Windows Server 2012 with SQL Server 2012 image. Okay. So we have a standard reporting services configuration screen here. I'm going to go through the standard steps of installing and configuring reporting services. So the first thing you need to do is check the service account, built an account, everything is fine. Then you have to go set the web service URL. Now, a side step here, this is one of the most confusing screens out there. Because to me, it looks like everything is done unless you actually look at and pay attention to that exclamation point in the yellow triangle, which says
maybe that's the apply button.
Yeah, it really isn't configured. It just looks like it's configured. So I hit apply, and it's going to go and register this URL for me. And then the next thing I need to do is actually create the database. Now, I'm going to go through this. It's a fresh database. We've never done this before on this machine. New report server database. I'm sorry, I have to follow a compulsion here. I can't see a test connection button without clicking it. Even if it does nothing, I always have to click it. All right.
That worked.
We're just going to take the defaults through this because it is a very, very simple system here. Now, what it's doing now is, as you would expect, it's creating the reporting services catalog database. In this case, since this is a gallery image, it has the SQL Server engine running on it. So I'm just using the local instance of the engine. So things could be a little bit sluggish. If you want to, you could spin up 2 virtual machines, one just to host the engine, one to run reporting services. My recommendation is turn off the services that you aren't using on that machine. Like I said, the engine is installed, analysis services is installed, reporting services is installed. Start, take the machine, let it spin up, and then turn off the services that you aren't going to use. Otherwise, they're going to be consuming resources that they don't have to consume, and it's just going to take away from the rest of your user experience. So this is almost done. As soon as this is done, we have one more step to do here. There we go, it finished. We need to set the report manager URL, and voila, we're done. So now I can actually launch this in the browser, and it's going to go out and connect to my local machine. In this case, I need to...
So that was it. So basically what we saw is there's actually no real difference so far, right? Between
exactly. No difference so far. I'm going to turn on my intranet settings on this machine. Yes, I want to do that. And now it's going to launch this. So what we're doing now is we're launching into the RS portal. Again, the first thing you're going to do after you configure reporting services, you're going to go in and provision users and deploy reports. Okay. So I have a reporting services user that I can provision on this machine that we are going to let them be the user that I connect with. Now, in a real production world, I would set up a security certificate and have SSL because we're going to be authenticating and passing passwords around. That basically, this is a case of do as I say, not as I do, because I don't have a certificate loaded on this machine. So we're going to pass this password in clear text. It's a dev password. It's not anything secure. I don't have anything out there. So don't worry, I'm not compromising any data here, boss.
That's fine for the next hour.
So, all right. So while this is running, this can take a while to run on the first time. We're going to talk about actually, it's up, so I will just go ahead and do it. I was going to go in a different direction, but it's ready for me. So I have this user. I'm going to give them rights on this site. So just like you would with normal reporting services, I'm going to set my security. This user is called MVA-bin-rs1, and it's RS end user. And they are going to be admins and system users. And just because I like to, I'm going to set them up on this specific folder as well. So it's MVA-bin-rs1, RS end user. And I'm going to give them a bunch of different rights here. Okay. So now that user is set up, and as you can see, we have no reports deployed here.
Can we change that?
Yes, we can. And the first thing we need to do is be able to access this machine from the outside world. Because you don't want to have to log into this machine, remote desktop into it, to run your reports, they'll upload your reports. The whole point is to be able to get at this machine from anywhere. So that's why we're using the cloud.
Do we need to do anything at the machine, the virtual machine level? Do we need to do anything at the portal level, both?
Well, the first thing we need to do is we need to come into the Azure portal. So on this machine definition, we have something called an endpoint. Now, when I go back to the dashboard, you'll see here I have a DNS name of mvabin.cloudapp.net. That is a publicly registered DNS entry that I can get to from anywhere in the world. This is on the public DNS. And we'll see if I scroll down, it actually has a public IP address. That is my gateway into this virtual machine. Now, when I go over to endpoints, these are the holes that I'm poking to allow me to get through to that virtual machine. So what I need to do is I need to add an endpoint for HTTP. And what this is going to ask me is what protocol do I want to use, what public and private ports do I want to use. If I had multiple machines here, I could actually set up a load balancer, and it would load balance my incoming requests between the different machines. In this case, I only have one, so I'm going to go ahead and create that. Now, you'll also see here that I have a RDP endpoint set up, so I could remote desktop into that machine. You'll notice that one has a different public port than the private port. That's something that we recommend. Obfuscate your port numbers, because the well-known ports, if you leave them open out to the internet, who knows what could happen. So just, the well-known ports, either obfuscate them or take them off completely. So what it's doing right now, what Azure is doing, is it's going out and reconfiguring itself and creating port 80. So now I'm able to address by this DNS name. So I'll just copy that and paste it to prove that. And I'm going to open I'll use one of these. So HTTP.
Should just work.
And we have to go to reports, because that's the report manager URL. And with all luck, it should come up.
Perfect. So that was fast. That was easy.
Well, it's not done yet. It's running.
Okay.
I'm connecting over the internet, going out to that machine. Yes, this is all happening over the internet. So it's not a local connection. It's a little, sometimes can be a little slower, can be a little painful at times. So how about that weather today? It's a little rainy out there.
A little bit.
So
it's winter season in Seattle, right?
What's happening now is it's actually going out, and this operation is going to fail.
Is it?
It is going to
rehearse, though.
We did rehearse, but this operation is going to fail. And the reason it's going to fail is because while we set up the endpoint in Azure to get out to that machine, we did not go in and set up the firewall rule on the machine.
All right.
So even though we set it up in Azure, it does not, the firewall on the machine still wins. So we have to go out to that virtual machine and actually set up that firewall. So if I come in here, I can go to my control panel and Windows Firewall. And I'm actually going to just add a firewall setting. I'm going to do an inbound rule. I'm going to do a new rule for HTTP. So I want to do port 80. I'm going to allow the connection. for any of my networks, and I'm just going to call it HTTP. Okay, so now that has been created. So if I come out and I try that again, this time it should prompt me for creds. I love it when demos don't work right.
It is working. It's taking its time.
It's taking its time. So I'm going to go see if this machine is actually doing anything. And you'll see here that this is a standard virtual machine. We can see that we have Task Manager running. We have a 4-core machine here. And that our processes, we have all of our processes running here.
You're not trying to buy time, right?
No, not at all. I would never do that. So, okay. For some reason,
I give you that. I trust you. It's working.
For some reason, this demo decided that it didn't want to work properly. So, the next thing we're going to talk about, though, is how do you get reports up to that virtual machine?
So to that point, you actually need to connect into the VM and remote desktop into it and copy and paste or upload, or how would you do that?
You could do that if you wanted to, but what the easy way to do it is just deploy from the tools you're used to.
Like
so if you have an
Studio.
RDL file, you could open the portal and just upload the RDL file. If you had a project in Visual Studio, you could just take the URL of the report server and plug that into Visual Studio as if it were a URL on your local network. So where if you were on the LAN, you might just put in the machine name /report server. In this case, you would put in mva-bin.cloudapp.net/report server. So that's how you deploy your reports. The one difference is it's going to actually prompt you for credentials. So when you try to deploy, it's going to ask you for a username and password of a user that has the rights to deploy.
So essentially what we learned is the only difference that we have between on-prem and in the cloud right now is make sure we define that endpoint and make sure we open the firewall, which you would do anyway, right?
Exactly.
And then everything as usual, basically.
Exactly.
Okay, sounds great. So I guess we talked about how to use VMs and gallery images. The next logical step would be how to not use them, right? And what would you do if you wanted to basically build your own image? How would you do that?
So that's an option that we give you in Azure. So you have the option to bring your own image up to the cloud. I've seen people do this where they'll build a machine on-prem, take the VHD file, and upload it into Azure. You also have the ability to sysprep a VM on-prem and upload that to use as an image that you use multiple times. Now, one of my personal favorites is to actually build my templates and my images in Azure. So I would start from a Windows Server gallery image, and I might install a sysprep version of SQL Server. I might load any custom code that I need for multiple machines. So if I'm using a reporting services, custom data provider, or custom extension, I could load that on my machine and then sysprep that, so I can create multiple instances of it.
So how would that work license-wise?
From a licensing perspective, the Windows Server license you're still paying the licensing costs on a per hour or per minute basis. This is a case of bring your own license for SQL Server, though. So where the gallery images are pay by the minute licensing, it's an upcharge to the standard licensing. With this, it's bring your own image or bring your own license. So if you have software assurance with license mobility, this is the option that you really want to use, where you're actually taking advantage of that license that you've already purchased. That's where this really comes in, and you have to use this. If you're using the gallery images, you're going to be paying by the minute, even if you have your own licenses. So the other thing about this is the storage options that we talked about before. They're going to be the same if you do it this way or if you do it the other way.
So I guess now it's time to maybe actually show how you can actually do that. I think there's going to be some scripting involved, even though you could do a lot of things in the UI. There's also ways of automating it, right?
I am going to show the scripts, but we're going to do it through the management portal. So the first thing I want to go do is go into the management portal and show you my storage account. So I have a MVA bin storage account. And you can see that I have something called containers. Think of containers as just a bucket for your bits. So I have an uploads container that happens to have 2 VHD files. One of them called MVA bin disk, the other one called MVA bin image. So what I want to do is I want to turn these into a disk and an image, and I'll explain along the way what those different things mean. But the first thing to ask is, how did they get there in the first place? So we uploaded them. There are third-party commercial tools that you can use to upload them. I happen to use an Azure PowerShell script. So if I come over to PowerShell here, you can see here that I have a command here called add Azure VHD. What this does is it takes a destination and a local path. The destination is where in blob storage do I want that to end up. The local file path is the path on my local file system where that VHD lives. Now I'm not going to actually run this here because VHDs are generally large files and will take quite a while to upload. So I'm going to just zoom in so we can make the font a little bit bigger here. So the first thing is, this is how you get it up there. Then we want to talk about creating disks and images. Now there's a little bit of a difference here. A disk is a VHD that can be used as a part of a VM. It could have an operating system on it, it might not. If you are just attaching storage, like I mentioned that you can have 16 storage disks on an extra large VM, those are disks, but they're marked in Azure as they don't have an operating system. They can just be attached and store data. They're backed by VHDs and blob storage. You can also, and what this command is doing is it's attaching a disk from a certain media location, giving it a name, and then saying, this one contains an operating system. That tells Azure that this can be used to create a new VM. Now, you'll see that the add Azure VM image is the same core command. It's got a different parameter name, but the command itself looks very similar. The difference is what they do on the back end. A disk is something that you can use to create a single VM. So I start with a disk, I create a VM around it. That disk is then bound to that VM, can't be used for something else until I destroy that VM definition, and I can then reuse the disk. But it can only be used by one VM at a given time. An image is, think of it like a template. What images are is they're sysprep templates that you can use over and over and over to create multiple VMs. So if you have a situation where you want to have, like I mentioned before, the software preloaded and then create multiple VMs off of it, an image is the way to go. So this is how you do it through PowerShell. I can come into the portal and actually come in here, and under virtual machines, you'll see that I have a tab for images, and I have a tab for disks. If I wanted to do an image, I would come and say create. I want to browse my storage account to that image URL and give it a name. And here's where I tell it what operating system it has. And I tell it, yes, I have run sysprep on it, because if you haven't, you're going to run into problems. You need to run sysprep on these. So when I say OK, it's complaining about my name. There we go. What it's doing now is it's registering that VHD as an image. And once that's done, we're going to be able to go in and create new VMs off of that image. Now I can do the same thing with that disk that I had uploaded. I come to the Disks tab and go to Create. I'm going to call it Demo Disk. And I'm going to browse for it. It's in my uploads. There it is. And this is where we tell it, does it contain an operating system or not? If it's just a disk full of data, I would not check it contains an operating system. But since it is not, it's meant to be an operating system disk, I tell it the VHD contains an operating system and say which operating system it is. When I say OK, Azure is going to go through and provision that. Once that's all provisioned, we could then go in and say, I want to create a new virtual machine off of that existing image or that existing disk.
And so it would actually show up in the gallery and...
Yep. So it looks like it's done. I'm going to come in here. Sometimes you have to refresh. I'm hoping I don't this time. All right, so there is, I had an image in here from before, but there's the image that I just created. I could select this and then create a new VM off of it, or I could take this disk that I just created and create a new VM off of it, but this is a single use. Once it's attached to a VM, I can't use it for a different one.
Excellent. So I think that wraps it up in terms of how would you basically build your BI environment, either using the portal or creating your own image. I guess it's a bit simplistic right now because what we've been talking about is a single machine, right, basically. Yes. So obviously in most BI environments, what you actually need is a bunch of machines, like a farm, BI farm. And so I would like us to take a moment to talk about a little bit, what do we mean by a farm? Are we talking about multiple backend servers? Are we talking about multiple front ends? Are we talking about multiple data warehouses, analysis services? Can you clarify a bit that?
Absolutely. And this is where, before when I was asking, is networking part of BI? Is Active Directory part of BI? This is where it all starts to come together. A few months ago, I wrote a paper about building a scaled-out farm in IaaS.
I know you did.
I know you approved that paper. So the paper, what we do is we go through building a 10-server SharePoint farm to run BI, and we do it all in infrastructure as a service. This isn't going to be so much building that as a demo because to do it end-to-end takes about 10 hours, and I don't think that people want to sit there and watch me click and run PowerShell for 10 hours.
Well, I would, but maybe we can focus on...
I'll hold you to that one of these days.
Maybe we can focus on the big picture and you can talk through,
So yeah, what we did, I'm going to switch over to the architecture diagram for this environment that we built. And you can see here that it's we have the big cloud all around it because it's all hosted in Azure. And the spine right in the middle is the network. We created a network and have multiple subnets to have all these different machines hosted in them. Then from there, we decided, and I want to emphasize, this is not a reference architecture. It is not a guideline for any type of BI workload. This was just an example of how do you do this in Azure? How do we actually get a scaled out implementation running in Azure? So the first thing that we had to do is we had to set up an Active Directory because SharePoint requires Active Directory. So we set up in the upper corner here our Active Directory subnet and multiple Active Directory servers. And the reason I say multiple is in Azure, if you want high availability, you have to have multiple machines running at what I'll call a role. In our case here, Active Directory would be a role. The backend database servers to host the content databases would be a role. The web front ends would be a role. So to achieve high availability, you need multiple servers running at that role, just in case one of them goes down. Whether it's planned maintenance or unplanned server outage, VMs do go down. It happens on-prem, it can happen in Azure. So you couch yourself by having multiple servers at that same level running the same tasks, so that if one of them goes away, the other one still exists. So we started with the Active Directory. The next thing we had to do was build a highly available database tier to host the SharePoint content and config databases. Well, to do that, we spun up, and that's in this other corner here, we spun up 2 SQL Server instances. Now, we did not use the gallery images for any of this. We did all these installs ourselves, and in some cases, we did sysprep things to make the installation of future machines easier. So we installed 2 SQL Server instances, and we set these up in an always-on configuration, always-on availability group pair, so that one can fail over to the other. SharePoint looks at them as a pair. It will use the one that's up and running and is marked as the primary server. From there, we built 2 more database servers. Those database servers are running analysis services in SharePoint mode. These are the ones that end up hosting our Power Pivot workbooks. Now, the nice thing about SharePoint 2013 is those don't have to be SharePoint servers anymore. It's just SQL Server running on there. So that's what we have running up there. Then we go down to the bottom here, which is where we have the SharePoint infrastructure. We built 2 SharePoint app servers. Again, do it in pairs or more because you need that for the high availability. So these machines are both running the core SharePoint services. They're also running reporting services on them. So I have that scaled out between these 2 machines. Then over on this other corner here, we have our web front ends. Again, we did 2 SharePoint web front ends to handle our incoming web traffic.
So how do you load balance basically between those web servers?
Okay, so what we did is we have both of these These are the only 2 machines of the whole configuration that are exposed to the internet. Everything else is private on the Azure Virtual Network. So what we did is when we set up the endpoints, you have the option to set up a load balanced endpoint. So it's the same incoming port gets spread between any of the machines that you put that load balanced endpoint on. So that's something it's a built-in feature of Azure. Nothing we had to build separately. All we had to do was define the endpoint properly.
Azure is basically taking care of it in the background.
Absolutely. So we did this, when we did this, we did it through SSL. We did certificates. We took the time in the paper to make sure certificates were loaded. So we were doing secure communications because we were using, not encryption, but authentication, passing passwords around. So the whole flow is from the bottom left side of the screen here. We start at your client computer. You come in over the internet on a secure URL to the Azure Load Balancer. That routes you to one of the SharePoint web front ends, which then does the work of working with the SharePoint farm and distributing the information back out to you. Now, the reason I say this isn't a reference architecture is because your architecture is going to really depend greatly on your workloads and your needs. You might have workloads where they are very dependent on the web front end, and that's the heavy part of the system. You might have workloads where the Power Pivot servers are the ones that are working the hardest. You might have workloads where the app tier of SharePoint is working the hardest. This is for you to monitor. These are VMs. They're no different than VMs on-prem. You can actually hook this network up to your local network through a VPN tunnel and use your existing monitoring software to monitor these VMs in the cloud. They can become part of your infrastructure. So what you're going to want to do as you do this type of thing is watch your patterns. Watch what's happening on your system, just like you would with any other server you're building. You want to monitor it, you want to keep your eyes on it, and you might notice a pattern that, say, from 10 a.m. Eastern to 2 p.m. Eastern every workday, our web front ends can't handle the load. This is where Azure really comes into play. Because what you can do here in Azure is you can scale out very, very quickly.
So can you also scale back?
Yes. So now imagine in your world of IT, if your IT department had to carry the capacity sitting in their data center unused to be able to spin up 2 machines, spin back 2 machines at any given time at the drop of a hat, your accounting department, your IT department would probably be happy to do it. Your accountants aren't going to like that too much.
Or we'll still be paying for it.
It's a lot of capacity sitting there unused most of the time. Well, in Azure, what we can do is we can actually spin up another machine. The machine's normally provisioned within 15 to 30 minutes, depending on the image that you're using, and you can add that machine to your farm. We could set up a schedule that, okay, at 9 a.m. I'm going to add 2 more web front ends. At 2:30 p.m. I'm going to tear down those 2 web front ends. So they're there and running processes for our peak load times, but we're only paying for it during that peak load. And we spin it back down at the end, and then tomorrow we spin it up again, and we spin it back down. So you can really, if you really monitor your systems, you can scale up and down and really control your costs and still give your users a great experience.
So that is really the promise of elasticity that the cloud gives you, right?
Yes.
Over your prem.
You know, it's the machines are there ready to be provisioned in the data center. You don't have to have them sitting in your data center. You just provision it when you need it.
Okay, so I think hopefully that gives a great overview of the architecture, like one possible architecture at least. What if the audience wants to learn more about how to actually do this, how to actually deploy the kind of architecture we showed?
Well, we've got 2 articles published on MSDN. The first one is how to do all of this on a single server, a full SharePoint farm, including Active Directory on a single server. Not anything you'd use for production, but it's a great learning environment for you to play around, and it's not going to cost you a lot of money to spin up 66 cores of processing power. That's what the paper took. It was 66 cores of processing and a lot of memory and a lot of storage. But it's more geared toward someone that wants to learn how to do a production-style system. We also have that paper out there on how to do this scaled out. The 2 URLs are up on the screen. The bottom one is the scale-out paper. That paper is 86 pages. It's mostly PowerShell scripts.
Oh, so it's not just pretty pictures, right?
No,
it's actually code that
it's
works.
mostly PowerShell, and the PowerShell will walk you through building out that exact environment that you saw in the diagram. if you follow every PowerShell script in there, you will end up with that environment you set up in the diagram. Provided your subscription has enough resources, you will have to request more resources because by default you get 20 cores. That needs 66 to run.
Okay, so I think that wraps it up. So basically, we talked about what are the pieces of a BI infrastructure in the cloud. So we saw there is some BI pieces and there is some infrastructure pieces, and you need to be aware of all of them. That's number one. Then we saw how you can use a built-in image, basically from the gallery, to spin up your own environment. Then we saw how you can work that around basically and build your own environment and then upload it into the cloud and use that to either spin up one VM or a multiplicity of VMs. And then we talked a little bit about scale out basically and how an architecture with multiple front ends and back ends would look like. So with that, I'd like to thank you, Chuck, for this content. I would like to thank our audience as well for being with us today. I would like to remind you that, hey, there is an MVA community out there. So thank you for attending again. You actually earn points as you do that, and hopefully you help us make this content better. So please don't forget to vote in the poll. That is giving us good feedback and help us improve in the future. Thank you so much.